Vai. Ai,
Good afternoon, students. Can you hear me clearly? Yes. Okay. Yes. So, are you ready for today's class? I hope you remember we had met long back and we had discussed something about the progressions. Yes or no? Do you remember? Yes, we had discussed about arithmetic progression. No, I won't be starting with the new chapter today because I will be continuing with this. Okay, we are whatever we have stopped. No, that I'll be finishing by most probably by Tuesday. Okay, so I'm trying to finish. So today we'll quickly finish all the three progressions. We'll discuss what are the formulas we come across in that, and after that, what we will be doing is we will be discussing little bit of. Yes, you can message that, you can chat. I mean, like in case if you have a doubt. Otherwise, okay, you can. If you have any doubts, yes, you can. Okay. Yes. Good afternoon. So, shall we start with before we start with today's class? So, let me quickly recall whatever we have discussed in previous class. We have discussed about arithmetic progression. Okay, in that we have discussed what is the nth term, that is an is equal to a plus n minus 1 into d. We have it displayed on the screen, and also we have discussed the sum of first n term. Okay. Okay, yes, Pratyusha, yeah, I'll try to share this only because this, see what happens is like one page has one equations and almost of the time. So what I thought is it will be better if you have a continuous notes. That's why I had shared a Word document. Okay, so if you have any doubts, you can always ask me through the email. I'll just try to reply. Okay, yes, okay. And okay, now let us continue. We had discussed about the sum of first n terms where we had discussed Sn is equal to n by 2 into 2a plus n minus 1 into d. That was the next concept which we had discussed. And also I had discussed, suppose if you have here the nth term instead of this d and n a all that, you can use the nth term. In that case, the formula, this formula changes to Sn is equal to n by 2 into a plus an. Okay, an is the nth term. Okay, yes. So that is black. Okay, I am not doing anything. This is the what we had discussed, and we will be discussing other special sequences and all that later on in the next concept. Is that clear to you? So today, what we will be doing is first we will be discussing whatever basic concepts are there in all the three progressions, and then we will be proceeding with the other concepts. Is that okay? So now, shall we start with the next concept? So you have to remember Sn is equal to n by 2 into 2a plus n minus 1 into d. If you don't know the nth term, if you know the nth term, the formula changes to n by 2 into a plus an, or it may be even a plus l. Is it okay? Fine. So now let us move on to the next one. Okay, that is the next concept. So I'll be moving on to that. The next concept, what we were discussing in the last class, is the application problems. Okay, so did you do this here? I had given you some work. Whether you were able to do it? Yes. What about the answers? I think answers of the first problem has been done. Okay, you had given me, it was 2062, something like that. Yes, we had discussed about that answer. What about the second one? What is the total? Yes, some of them had given. What about the second one? Did you find out? In the second one, Earth's circumference is about or about 40,000 kilometer, and every day, here question is missing. Every day it should be, the Earth does a complete rotation, which means if you do nothing and stand in one point on its surface for a day, then you will have done a 40,000 kilometer lap around the center of the Earth. So, what is the total distance of all your laps around the center of the Earth for a week? Okay, so is that the okay? Yes, Amit, yes, it is correct. Okay, I'm getting answer as okay, yes, 2,80,000. Yes. How did you get that? Okay, yes. It is the arithmetic progression with the common difference 40,000. Okay, correct. The first term of the arithmetic progression will be 0, right? Yes or no? Yes. First term will be 0, and after that, the second, after that is after completing one lap, the second term will be 40,000. So like that only you continue. Okay, yes. So now correct. Okay, yes. So they have done it. So you can do it. Find the arithmetic progression. Okay, yes, it is. Just you can do that. It's left to you if you want to multiply. Okay, yes, that's correct. Yes, yes, it can be even 40,000 into 7. Okay, yes. Okay, here. So how do you solve this? And how do we start solving this? Anybody can tell me first what I should do? First, here somebody is asking me to show, so I'll be using that. So what we do first thing is, here we have to write the AP. So first day our distance traveled will be nothing but 0. Yes or no? Because we are on the same place. Okay, and we are not doing anything, we are standing there. After first day the distance traveled will be 40,000 because you finished 1 lap. Yes, correct. Okay, next after that what happens? The next day. Next day what happens to this? Again it becomes yes, because what happens? You will finish on the second day along with this 40,000 the next this one. Okay, so like that you have to continue for how many days? 7 days. So 7 days, what it will be the answer? 7 days. Okay, next again 40,000, so it will be like this. Are you getting it? So on 7th day what will be your answer? Okay, I think I have already discussed, Amog, what is the formula for Sn. Yes, so like that. Why zeroth term is 0 is the first term? Because you will be standing in one point. You have not finished the 1 lap. That means you are just starting at that point. So it will be 0 there. Once you finish 1 lap, it will be nothing but the 40,000. Because what happens? You are finishing one rotation. So the distance traveled by you on the second day will be 40,000, not on the first day, because first day you will be standing at that point. You don't rotate, right, along with the earth. It is like that. You are rotating about its axis. So that won't take place. So after this, on 7th day, what it will be? Can anybody tell me? This is first day, second day, third day, fourth day, then again after that. Okay. Again you go for next 40,000. Correct? Yes. So again, continue further. Continue. What you will get? Like this only, you have to give me the answer. This is on 5th day. Then on 6th day, it will be how much? How much it will be? Is it 20? Sorry. Yes, correct. What it will be? Anybody can tell me? I have to add here how much? Yes. Mitul, it is because we are on one point. Okay, please remember we are on one point. We are not moving. So on the 7th day, the distance traveled will be, what is it? Anybody can tell me? It will be 2,40,000. Okay, 2,40,000. 2,80,000 will be on 8th day. Okay, so here if you don't take this, here your answer will come as 2,80,000 on 7th day itself. The reason is, here we are not starting the lap. We are starting the lap only on the second day, because what happens is on the first day you are just starting, you are there, you are standing still there. Okay, fine, you are standing still there. Okay, yes, formula is an, because here you just have to find the total distance. You can do it like that. Okay, yes, nth term on 8th day, what is that distance you finish? Is it clear to you? If the sum is given, then the formula will be ASN, not AN. Those kind of problems we will be doing it later on. When I give you a generalized problems and all, I'll give you. When it comes to, the total amount is given for example, maybe we can say a scholarship. A school is paying certain amount of scholarship and they want to pay it for 10 students. Okay, in that case, there the sum is given. Their SN formula. Is that clear to you? But here it is nothing but here we have to find the total distance traveled on the 7th day. So it will be 2,40,000, not the 2,80,000. Is it fine? Clear to you now? Okay. Yes. So here the reason is, why do we get that answer? Because on the first day we take 0. We don't take the first day as the 40,000 itself, because you are just starting there, you are standing there on the first day, and the next day what happens, by the end of the next day you will finish 1 lakh. So that is why you have, is it okay? So that is what we have. Okay, clear to you? Yes, it is the beginning. Yes, it's just we are starting there that day. So that day it is beginning. We just stand there. And then by the end of the next, after 24 hours, you finish the 40,000 distance. It is like that. Is it okay? Fine. Okay, Anika, I'll give you examples for SN. Then you will be able to understand the concept clearly. Is it okay? Fine. Okay, no need. All the AP need not start with the 0. You don't have to start every AP with the 0. It depends on what kind of situation we have it here. Is it okay? Yes. Here we have used AN, you can use. Here the common difference is 40,000. First term is 0. Is it okay? You will get easily. Okay, yes. So next, okay, these are the few application problems where we will be solving, which is based on again the AP. Okay, so the first question here asked here is which term of the AP, which term of the AP 121, 117, 113 is the first negative term. Now please understand the question. They are asking, they have given you the AP and they want you to find out which term of this given AP is the first negative term. So in that case, they are trying to ask you what is the position of the first negative term. I hope you are able to understand what is the question, right? So shall we start? How do we start here? So they are telling which is the first negative term. So that is why what we do is we start here with an is less than 0. Please understand, we start with the an is less than 0 because the first negative term we need to find in this AP. Yes, yes, Ketan, it is correct. So in that case, what we do is first term means we don't know what is that nth term. So we take an is less than 0. See, they are asking you, they have given you this AP. In this AP, if you observe, the common difference, that is D, is 117 minus 121. What is your answer? Minus 4. So you can observe the difference is negative. So this AP just goes on decreasing. At certain point of time, the AP terms, that is whatever terms you get here, will be negative. So you have to find out which position has the first negative term. Please understand which position has the first negative term. That is what they are asking. They are not asking you to find the first negative term. They are asking what is the position. Okay, yes. So you can do this. Okay, now let us continue with this. So here, how do we start? Okay, so the first thing is we note down whatever answer information is given. First term is 121. We can find D, and we have to find out what is the value of N. Okay, yes. So Shashank, you are not right. You just have to check your calculation. Okay, so now AN. What is the formula for AN? We know AN is equal to A plus N minus 1 into D. Okay, be really careful. Okay, no need of trial and error method. You will understand using this method. This is very simple. So now let us start. We don't know N, but we know this. So let us substitute that 121 plus N we don't know. Keep as it is. But what is the common difference? Minus 4. Okay. So do that. Again, you know this formula. So I'll be raising it. So here, after that, you will be using less than 0. Now continue. Okay, yes, Sakshi, yes, you are correct. Okay, Satvika, you can't have the number of terms as the fraction. Please understand that. So here 121, multiply this. So this negative term here, Here it will be minus 4n, and then minus into minus it will be plus, less than 0. You shift it this side, you will get 125, because 121 plus 4 is less than 4n. Now please understand, I'm just shifting, I'm not changing the sign. Okay, so you will get n is greater than, okay, you understand that, 125 by 4. Approximately this will be equal to 31/4. Is it correct? Yes or no? Correct. 1 remains. I am just converting it into mixed fraction. From this expression, we get n is greater than 31/4. So that means after this 31st term, whatever comes next is nothing but it is the first negative term. So 31st term, it is more than that. 31st, you can understand, 31st term is not negative. N should be greater than 31/4. That means the next integer is 32. So next integer will be the first negative term. That is why n is equal to 32. Please understand, it says n is greater than 31/4. So n value should be the next integer which is greater than 31/4. So it is not 31st term, it is 32nd term. Is it okay? An is less than 0 because they are asking which is the first negative term. Is it okay? Yes. So your answer is nothing but n is equal to 32. So according to that, 32nd term is the first negative term. Is it okay? Actually, I have not shifted. Here it is n is greater than, I've just changed it, and so that you will understand. That's why I've written. Okay. Yes, fine. Okay, yes. So that's it. Mithul, check it properly. Okay, that's it. So this is how you calculate. Whenever they say which term is the first zero, or first, what we can see, sometimes they may ask which term of the given AP is 0. In that case, what you do is you put n equal to 0 instead of less than. Is that clear? Suppose if they give you here negative AP in the sense there are some APs which start with the negative term and their common difference remains greater than 0. In that case, you can go for AN is greater than 0. Is it okay? Fine. But be really careful when you have negative on both the sides, because when you multiply or can by -1 on both the sides, inequality reverses. So you should be very careful about that. Okay, I think you have learned last year about it. Okay, so this is what we have. So n is equal to, they are just asking which term is its, which first term of the AP is its first negative term. So if you find the position, it is enough. You are not asked to find the term. If they ask you to find the term, okay, then you can go for the formula AN is equal to. Is it okay? So if you want to find the this one term, it will be like okay, AN is equal to A plus N minus 1 into D. Is it okay? So this is what we have. So then A 32, right? So 32, and A is 121 plus N is 32. So 31 into minus 4. So this is what you have. So 121 minus, you get it as 124, which is minus 3. Is it okay? So first negative term is minus 3. Okay. That's it. They are just asking you to find the position, not the term. Okay. Yes. See, Sumit, if the first first term is negative, then we can't ask you this question. In that case, what will be the first positive term may be asked in case if the D is this one. Okay. Yes. But this is not formula for both. This AN is a general formula. This formula depends on the situation. I discussed all the three cases. You take AN equal to 0. If they ask you find the which term of the given AP is 0. In that case, you take AN equal to 0. If they ask which term of the given AP is the first positive term, in that case, you go for AN is greater than 0. Okay, all those different cases are there. So depending on that, you will change the inequality. Okay, yes, that's what you do. Okay, now we'll move on to the next one. Okay, yes, so this is again based on, please read the question properly. The houses are numbered from 1 to 49. Okay, try to understand. Okay, there are houses named like this. Okay, and then up to 49. So there, show that there is a value of x. You need to find one x which is in between this. Okay, please understand, such that the sum of the number of houses preceding the house numbered x. So sum of the, so suppose here is the x, you can, I just write it little bigger. Suppose this is x minus 1 x and then x plus 1 and then so on 49. Okay, so what they are asking is, you have to find, you have to show that this number exists such that the sum of houses, okay, sum of the number of houses preceding the house numbered x. So I need to find s x minus 1. Okay, that is equal to the sum of all the houses. Okay, sum of the all the numbers of the houses following it. Following it in the sense it is from here to here. So how do you find this sum? Okay, in order to find this, please understand. Okay, we have like this up to x minus 1 x, x plus 1 and so on 49. So you can easily find what is the sum here. It will be sx, correct? And you can find easily up to here, that will be s49. So suppose you want the sum from here, that is from here to here, then it is written as s, okay, s49, that is sum, entire sum minus sum up to x houses. So you get it like this, s49 minus sx. I hope you understood what I am trying to tell you. Okay, because the formula says Sn is the sum of first n number of terms. Okay, it says it's the sum of first n number of terms. So you can't find sum in between. So in order to find that, you need to use this logic. If you want to find the sum of all those houses, number of houses which precede, which what is that? Which follow x. Okay, please understand, not preceding, which follow x. That is, we need to find the sum here. If you want to find the sum of all these houses here, in that case, what we do is, we find the entire sum. Entire sum is given by S49, correct? Yes. And then you can find easily what is the sum Sx, because directly you can do it. Sx is equal to, right? So you have to do that. So Sx you get. So if you want to find the sum of all the number of houses which is following x, is given by S49 minus Sx. Is it clear to you? Is it fine? Okay. So what is they are asking is, according to the question, we need to prove Sx minus 1 is equal to S49 minus Sx. This is what they are trying to ask us. This is what we need to prove. Okay, this is what they have given in terms of words they have given. Okay, yeah, somewhat I can't say it is exactly the middle term. Okay, somewhat similar to that. Okay, yes, so this is what we need to prove. So now shall we start with the solution part? Yes, fine. Have you understood clearly why did I do this 49 minus Sx? Because we can't find this sum directly. So what we do, we find the full sum minus Sx. Okay, yes, clear? Any doubt? No, right? Okay, now we'll do that solution part. I'll be cleaning this. Please understand. Yeah, so it is like this. Please, okay, one. See, it is like this. House starts from 1, 2, and so on. You have x minus 1, which is the previous house of x. then comes x, then comes x plus 1, and finally last house is 49. So according to that, okay, according to that, what they have asked, they are asking us to prove is s x minus 1, that is the sum of number of all the houses preceding x, is equal to the sum of all the houses, okay, number of all the houses following x. So that is why following x is given by S49 minus Sx. Okay, okay. So we'll find, yes, yes, Ketan, it is correct. So now what we do is we can find this separately, each one, because we know the formula for Sn is n by 2, 2a plus n minus 1 into d. So here d is 1, a is 1, an is 49. So you can use it for S49. So S49 will be equal to 49 by 2. I'll not be using this for the 49 because we know the last term and the first term. So that is why I'll be directly using this formula. So you get it as 49 into 50, right? Okay, yes. Yes, yes. Okay, yes. Yeah, I'm using that only. Okay. It is not Sx plus 1 because we need the this one. What is that? Following x. Okay. So this is what you get here. A is 1. Last number is 49. So by 2. Find out what is the answer you get here. Okay. That is for you. You need to substitute it here. Okay. Then you can find Sx. Okay. Sx. You don't know the last this one. So please, okay, remember. Okay. 1. Okay. Correct. Yes. So you get the answer here as 1, 2, 2, 5. Yes. Correct. No, in that case, we will not. Shashank, I didn't get your question clearly. In what case you are trying to tell me that x is not included? Okay, here, what about this one? Sx. What do you get for Sx? You have x by 2 because number of terms is that. Okay, then you have first term is 1. Okay, if you don't want to do this, okay, I have used, you can always use this. Please understand. Or else you have one more choice, which is Sn is equal to n by 2 a plus an. So in this case, I am using this. Please understand, I am using this here. So 1 plus the last term, since I am finding Sx, x it is because I have written here. This is the last term I have. So this is what we have. So you can say x plus x square by 2. Then if you want to find Sx, x by 2, because I am finding some Sx, Sx. So n is equal to x here. Please understand. N is equal to x here. So then again we have n here s x minus 1. I've written properly again. Okay, so you will get x minus 1 into, okay, 1 plus x minus 1 by 2 here. So 1 minus 1 and this one cancels. You get x square minus x by 2. So substitute everything here. Okay, this is x square minus x by 2 is equal to S49 is here 1, 2, 2, 5 minus Sx, which is here. This is Sx and this is Sx minus 1. To substitute everything here, you get x square. Okay, x. Okay, let me write first x only. That will be better, I think. Okay, some of them get confused. Why did I write first? X plus x square by 2. I have substituted everything, whatever I found just now. Then shift it here, you get x square. See, common denominator. So I'll be taking that common denominator itself. Minus x Then when I get it here, see, it is minus for whole thing. So it becomes plus x square is equal to 1225. So this one minus x and plus x cancels. 2x square by 2. This one cancels here. You get it as x is equal to, what is that you get? X is equal to, actually you need to take the root of this. Okay, please understand. I'll write it here. X is equal to, okay, root of 1225. If you find out, that will be your answer. Now some of you may ask, why did I take positive? Actually it is plus or minus root of 1225. But if you observe, this is the number of houses. Okay, please understand, number of houses cannot be negative. So your answer is 35. Is it okay? Now have you understood? So this is how the application question come. You will be given, different kinds of question. You need to understand what is that they are trying to tell you and apply whatever formulas you know. Fine? Okay, now we'll move on to the next one. Is it clear to you? Okay. So next, are you able to understand whatever is okay, Shashank, what is the doubt you have?
Ma'am, can you explain the last part, please?
Last part, what I have done, is it? Okay. See, I have found Sx. You can see there, right? I have found, okay, let me use a different, okay. See here, first what I did is I found, what is this, correct? S49. Because according to question, we need to prove this. X minus 1 is equal to S49 minus Sx, right? So first I found what is S49. Then I found what is Sx. All using this formula I have done. There is no restriction that you have to use this formula. You can use this formula, whatever I have shown you here. Okay, you can see here, right? This also can be used. And then I found Sx minus 1. So what I did after that is I substituted everything in its place in the given equation. First is Sx minus 1, which is x square minus x by 2. That is here. This is the first substitution. Second one, S49, you get 1225 minus Sx, which is here. Can you see? X plus x square by 2. Now, since there is a minus, I've used whole bracket. Then what I did is I have shifted this whole thing from here to here. Correct? Then when I shift, this negative becomes positive. And then you can observe this denominators here are same. So what I did, x square minus x plus this x comes here plus x, because this minus becomes plus, and then plus x square. Okay, once this is done, the next step is you add this x and this x cancels, then you get 2x square divided by 2. Cancel 2 and 2, and then you get x square is equal to 1225. In order to find x, you take the root. Don't take the negative root, because here it denotes the number of houses, and you know that number of houses cannot be negative. That is the reason we can't take the negative. But is it fine now? Have you understood clearly whatever we have done?
Ma'am, understood, ma'am. But how did you get to know that Sn is equal to Sx minus 1?
Sn is equal to Sx. See, what they have told you is you have to read the question there properly. If you observe, show that they are starting the actual question from here. There exists a value of x. That means they are asking there may be one value of x. How that value is? Such that, see, sum of the number of houses preceding x. Sum of the number of houses preceding x means we have to find the sum of numbers from here to here. Can you observe that? 1, 2 up to x minus 1, because preceding x is not included. So you need to add all these numbers previous to x. Okay, clear? Okay, preceding the house numbered x. Okay, after that is equal to, so I have put equal here, to the sum of all the number of houses following it. So number of houses following it cannot be found, because that sum falls in between the sequence. Correct? You know that it is here. It is here. This sum we need to find, but it is towards the end, in between somewhere. I don't have any formula to find the sum towards the end. Either I have an option, I can just remove D and then find. That is also possible, but then it will be another work. You need to find D again and all. So instead of that, what I did is, in order to find sum from here to here, I took the entire S49 and then I have subtracted Sx, that is up to here. From the entire sum, I need to subtract from here to here up to x, because I need only from Sx plus 1 up to this one 49. Correct? Up to that I need. That's what I did. Okay. So that's how I understood that I have to take it like this. I hope now at least you got an idea. How did I take every concept here? Okay. Yes. So now shall we move on to the next one then? Read the question properly, you will get an answer. Okay, yes. So now this I'll want you to solve it. Okay, I will not be doing it, I want you to solve it. It will be very easy. Students, I don't know whether you are you able to see the board clearly, I mean PPT slide clearly, whatever I am writing. If you're not comfortable with this, I'll just shift to the Microsoft board where I can write little bit thick. This is bit I mean like it is very thin, I don't know whether it is clear. It's okay. Okay, fine. So in case if you have any problem with that part, just let me know. I'll shift to the another writing pad. Okay, so that it will be little bit thick here. Okay. So now here, what is this? Okay, please understand. This is again a real life application. Okay. Yes. So that and all I'll be discussing. So what is it? Okay, there is a small terrace at the football ground. Okay, which has how many steps? It has 15 steps like this. Okay, then again it is like this. I know I'm not that good artist as such, but please try to adjust it. Okay, I'm trying my level best to draw somewhat correct figure. Okay, somewhat like this. Okay, so I hope you're getting an idea how is it. Okay, so this is how it is. Fine. Okay, so they have given, okay, each of which are 50 centimeter. Okay, it has 15 steps like this. How many steps are there? There are 15 steps. Okay, I'll explain the concept, please understand. There are 15 this one. Okay, yes. Okay, yes, so that's it. Okay, yes, so this is how is the steps. So here they have given, okay, try to understand. They have given, okay, here this is the length. Okay, length is 50 meter. That is what they have given. Okay, it is built of solid concrete. Okay, that means it has a wall. It is a solid 3D shape. Okay, each step has a rise of. What is the meaning of rise? That is, they are talking about the height. So this is yes, Shashank, it is correct. Okay, so rise of 1/4. This is what is the height. But remember, this height keeps on increasing. Once it is 1/4, for the next step again it increases by 1/4. Okay, yes. So next again, what is the thread? Anybody can tell me what is the thread? This is what is this. Okay, this is what is the width of that step. So that is 1/2 meter. So this is how it is. So now you have to find out what is the volume of the concrete required to build these many steps. So this is how it is. So first step has the volume of, okay, it is the cuboid. So length into breadth into height. Okay, so it will be like 50 into breadth is half, height is 1/4. So what happens to the second one? In the second one, this will remain same, that is the length and the breadth. But what happens to the height is, height becomes double of what is there in the initial stage. Because what happens, this is 1/4, again this is also 1/4, so it becomes double. So in the third case, 50 into half into this height, which was 1/4 in the initial stage, in the second stage again 1/4, will become 3 times of 1/4 like this. So go on doing this up to how many terms? Up to 15 terms. So find the sum. Yes, most of them have got the answer. Nidhi, just can you please check the calculation? Okay, I think somewhere calculation went wrong. Okay, yes. So that is the answer. Yes, Ketan. Your answer is correct. Okay. Yes. So now is it clear to you? Yes. So some of them have given the answer. So now can you solve this? Is it possible for you to do it? Which formula you have to use? Can anybody tell me? Since you want the total, they have clearly told you total they want. Yes, you have to use SN. Anika, you were asking, right, when you use SN formula, right? Yes. So see here, they are clearly specifically telling you calculate the total volume. So that gives you the understanding that you have to use the SN formula. Is it fine? Yes? Okay. So this is how you do it. I want everybody to solve this and come back in the next class. Is it okay? You can do it? Fine? Okay, Shashank, that is okay. Yes, you can use it for the second half. I mean, first you need to take certain number as a common term, and then you can use it, Shashank. Okay, yes, that is the sum of first is integers, first n integers of a given. But be careful while you doing it. Okay, yes. Okay, fine. Yes, Nidhi, it is correct now. Now it is correct. Okay, yes. So that's it. Okay, so Satvik, I think just you need to check it. Okay. Okay, what you need to take A as. Okay, see here. First, yeah, first, yes, correct. It does not, okay, I'm sorry. First, positive integers only, not the negative integers. Okay, yes, Session. Okay. So this one, what you have to do is, first you need to calculate what is this. You get it as 50 by 8. Okay, take 50 by 8 common, then you will get the first 15 natural numbers. Okay, after that, Nihat, you need to calculate once again. Okay, please understand. Okay, some of them are not able to get it, how to do it. It will be like this, students. It will be like 50 by 8. Okay, comma 50. It is 2 into 50 by 8. That 2 is this extra 2. Okay, remaining everything is 50 by 8. Then again 3 into 50 by 8. Okay, 50 by 8 up to 15 terms. Okay, so you get 50 by 8 common, and then you have 1 plus 2 plus up to 15 terms. Please understand, it is up to 15 terms. So do this, you will get. Yes, it is 750. Who is that? Who has so much time to type everything? Okay, yes. Yes, Mithul, it is correct. Okay, yes. Yes, yes, Murali, it is 7. Yes, whatever answer you have told me. Okay, what is the difference? For which one, Anika? What is the difference you're asking? Okay, 750. Okay, so this is what you do. After this, you just use here. Okay, D value. Okay, fine. Difference will be 1 for this. Okay, this 5 by 8 remains outside, and only for this 1 plus 2 plus up to 15 terms. 15 terms, please understand. 15 terms it is. I not a 15 is a term I've written. It is up to 15 terms I've written. So 1 plus 2 and 3 and so on it goes on. For this only you will be applying. Please understand, only for this part you will be applying the SN formula. Okay, now by now you should have been able to do it. Yes, answer is some of you have okay, yes, okay, Shashank, no, it is not that answer. Okay, yes, many of you are getting. Answer is 750, students. Answer is 750. It's very simple. Just you need to apply SN formula. Okay, it is 750 meter cube. Meter cube. Okay, 750 meter cube. Okay, yes. So what is the this one is here? Okay, some of you were asking how it is done. I'll just show you. See, you had 50 by 8 into here 1 plus 2 plus and so on up to 15 terms, right? So 50 by 2 8 remains here. Apply SN here. That is n by 2, 2a plus n minus 1 into d. You will get it. 50 by 2. What is n? 15 terms, right? So n is 15. So 15 by 2. What is a? A is 1. Okay, A is 1, D is 1, and N is 15. So substitute everything here. Okay, 14 into 1. So this is how where you get your answer should be 750. Okay, so this is how you do it. Yes, so I hope you have done it. So next we'll move on to the next slide. Okay, yes. So next we'll move on to the very important concept. Yes, you can take a l also, but in that case you can you need to find out what is the last term. Okay, so now here arithmetic mean. So next, again, you are very familiar with the arithmetic mean concept. Again, here I'll be discussing very simple arithmetic mean. That is nothing but the what is arithmetic mean, all that only. After that, when we discuss about the advanced series, I'll teach you how to insert the arithmetic mean or how to use this arithmetic concept in higher level problems. Because what happens is, in that case, I'll be discussing everything in general. That is arithmetic mean, geometric mean, as well as the harmonic mean, and also the problems related to them. Little bit higher level they are, students. I'll be trying to pick only the few this one. Okay, inequality also we will be discussing, like how the arithmetic mean, harmonic mean, and the geometric mean are related. What is the relationship between them? That also we will be discussing, and the inequality also we will be discussing. Okay, so that we will be doing later only after finishing everything. Okay, yes. So now only the basic concept. What is arithmetic mean? And then we will move on to the geometric mean. Okay, yes. So now what is arithmetic mean? You all are familiar with this. Yes. Suppose if I give you only A and B, the arithmetic mean is nothing but it is A plus B by 2. Or in other words, I can say it is the you are just finding the middle value of the A and B. That is what you do here usually. So if you have A, B, C as three numbers which are in AP, then here B is always the arithmetic mean of A and C. Please remember, if these three are in arithmetic progression, then we can always write B as A plus C by 2. This is always possible. Please remember, you can check if you want. I'll give you one example. 1, 2, 3. Check. This is in AP. Yes, do you agree with this? 1, 2, 3 is in AP because with the common difference D as 1 and A as also 1. Okay. Now if you check 2, okay, I will take this and this. Add them. You know, right, how to find the arithmetic mean? Just add and divide by the number of terms. So you get it as 4 by 2, which is 2, which is equal to the second term. This is how we have. Okay, this is how we relate the AP, this one, arithmetic mean, or AM. This even comes in the concept of statistics. There also we have the arithmetic mean concept. Okay, yes. So now we'll move on to the next this one. So just I am giving you introduction. Arithmetic mean is nothing but you just have to find the sum, add all the numbers or all the and divide by the number of terms. Okay, so just remember, what is the arithmetic mean? Suppose you are, once again, just this one. Okay, just a brief idea. Suppose you have three numbers A, B, C which are in AP, then arithmetic mean of A and B is given by A plus C by 2, which will be equal to B. This is one of the notation. Or else if you want to find the arithmetic mean of A and B, then it is nothing but A plus B by 2. This is what we have. Okay, yes. There is a Sumit, that kind of concept will not be possible. In that case, we can't. Okay, yes. Yes, A plus 1 minute maybe. Okay, A plus T is equal to 2A. Yes, correct. That is also, that relation is also possible. Okay, yes. Okay, yes. Okay, what if there are even numbers? Even numbers, yes, possible. You can have the AP of even numbers, right? Even actually there is one more sequence, what is called as arithmetic progression of prime numbers, which I'll be discussing later on with the advanced series only. Okay, that is also there, prime numbers. There is one problem based on that. So that's why I've just kept it towards the end. So that I can finish all the basic concepts and then we can discuss advanced problems, students. Because you know, even in your textbook also, they finish all the basic things and then they are discussing different advanced series. Okay, actually there is something called as convergent and divergent series also. There is something called as limit concept also. Okay, yes. So in that case, that is see this one, Nihat, if A, B, C, D are in this one, then you can always find A, B will be the mean of A and C. Then C will be the mean of B and D. All that is possible. Okay. So you take any three consecutive terms in AP, their mean always lies in between those two terms, you know, last and the first term. That is always possible. Suppose if you take even numbers like this, 2, 4 and 6, okay, 8, then you can just, you know, find out. Suppose if I find the mean of these two numbers, that is 2 plus 6, you get it as 8, 8 by 2, which is 4. Okay, suppose if I want to find the mean of these two, you can check 6 plus 10 is equal to 16, which is 16 by 2, answer is 8. So all this is possible. Okay, even terms are there, then also it is possible. We can always find. So any three terms are in AP, then always remember they are the middlemost term is always the this one, arithmetic mean of the preceding as well as the following term. This is what we have, the relation between them. Okay, sometimes we use this in 1 mark questions and all that. Okay, if there are yeah, even number of terms, that need not be the case, because I showed you three need not be three terms. I had taken here 5 terms. If you want 6 terms also, you take. But what I'm telling you is, if you have 3 consecutive terms in AP, then the middle number will be the arithmetic mean of the first, that is the preceding and the following number. That is what I'm trying to tell you. The number of terms doesn't make a difference. Okay, we can't have it for 2 terms. In that case, I told you, if you want to find the arithmetic mean of 2 terms, then you have to add them and divide by 2. Okay, this is applicable only for 3. Yes, need not be. We can find the arithmetic mean of all the different numbers. You know, right? You do it in statistics. If you want to find the arithmetic mean of 5 numbers, yes, possible. Add all of them, divide by 5. That will give you the arithmetic mean. All that is possible. But just I'm giving you one more special thing. I mean, like what we can say is a special relationship. When 3 terms are in AP, then the middlemost number will be always the arithmetic mean of the preceding and the following number. That is what I was trying to tell you. There is nothing like you can't find the arithmetic mean. There is a possibility. You can see, even you can multiply. Suppose you have an AP, you just multiply entire AP by a certain number. Then your AP will remain as AP only. It doesn't change. Something like that. You understood? No, that becomes double. The common difference becomes double. Something like that. There will be, you know, addition of numbers doesn't make a difference. Subtraction of the numbers doesn't make a difference. Like that. So then also AP will be almost AP itself. Okay, if you if you subtract or add any numbers as such to the given AP, then also it remains almost similar. A arithmetic mean may change depending on, you know, what kind of number you have. Okay, yes. Okay, what is the formula for arithmetic? This one, mean of 4 terms is nothing but you just have to add them. Okay, suppose if I have, let us take here itself, 2, 4, 6, 8. Okay, what I do is sum. Okay, it is written like this: sum of all the terms divide by number of terms. I hope you have learned this in your statistics class. Sum of all the terms divided by number of terms. That is the formula for arithmetic mean. Okay, yes. So that's it. It's a very simple concept. Now we'll move on to the another further few questions which are based on arithmetic progression. Okay, just it is based on general. There is nothing like, you know, you have to use AN or something like that. In general, the questions are given. You have to identify what has to be done. Okay, now this is the 6th question from the textbook. Please understand, I have written the number here. What am I doing is I'm taking the problems according to, you know, our concepts. Suppose if we finish arithmetic progression, then I've taken arithmetic progression problems from your textbook. Exercise has very few problems. Workbook has many problems, and there are some activities also. I want you to try. I'll let you know which are those. Okay, yes. So now let us continue with this. So here is the question. A1, A2, A3 and A98 are the terms which are in arithmetic progression with a common difference 1. Please understand the important points here. These are there. These are in arithmetic progression. That's the one important concept. And their common difference is 1. Okay. Then after that, their sum is 137. What is the sum? Okay, yes, kid. So what is the sum of even terms of this progression? That is, what is the value of, suppose you don't understand what is the even sum of even terms of the progression. For that sake, they have given, that is, what is the value of A2, A4 plus A6 plus A98. So how do you solve this? This is very simple. Okay, we know that, what and all we know, they have given us common, we don't know what is the first term. Okay, first term is A1 itself is A. Okay, and they have given S 98. That is, there are 98 terms. Sum of those is 137. That's what has been given to us. And the common difference D is 1. This is what they have given. So what we do is, we know according to the given question, that is A1, A2 and so on up to A98. This much is 137 without leaving any terms. It is not considering or even or odd. Okay, just like that, they have considered whole terms, whole set of terms there, and they have added and they are getting 137 as the answer. That is what they have given. So S98 is this. And you know that S890 before that, okay, you don't have to apply here SN formula. Okay, please understand S98 is there. So N is 98, understand, but don't directly try to apply SN formula, because they are asking what is the sum of even terms. So now how to write this in terms of even numbers? Please understand, this is very important. Okay, here I want only A2, A4, A98 like that. So what I do is, I have A1, right? You know that A1, okay, just simple. A1 is related to A2 in this manner. That is nothing but A2 is equal to A1 plus D. Do you agree with that part? Yes. So here, okay, you get it here as, now please understand, D is 1. So you have A1, I'll keep as it is, this one here, and then I'll shift it here. So A2 minus 1. Same way I can write A3 as A4 minus 1. Same way I can write A97 as A98 minus 1. Okay, then in that case, if I do that, then here I'll get it as A2 minus 1. Okay, A2 remains as it is because I'm not going to touch the even terms. I'm touching only the odd terms like this. Okay, A3 will be A4 minus 1 and so on. A97, which is here, okay, will be A98 minus 1, okay, plus A98 is equal to 137. This is how you can solve it. Next here, how many these terms are there? Up to 98 there are. Okay, so how many times we can add A2? There is twice, so I'll have it as A2 twice. Same way I have A4 twice. Okay, how do you understand A4 twice? Because after A3 comes the A4, so you will have two A4s. So same way, if you continue, you have two A98s. Okay, 98s are 2. Now how do you understand how many ones are there? Actually there are 98 terms, okay, out of which, please understand, 49 are odd, 49 are even. So using this, there are 49 odd terms, right? So since there are 49 odd terms, there should be 49 ones. So add all those 49 ones, you get minus 49 as the answer here. I'm adding this 1, 1 and then this one. Okay, here. Please understand. So I get 149, 1. So I get minus 49 is equal to 137. Take it this side. Take 2 common. You get A2, A4 and so on up to A98. Okay, is equal to 137 plus 49. So you want A2 plus A4 plus and so on plus A98 is equal to, what is the answer here? 186. Is it correct? By 2. Your answer is 93. Is it correct? All are getting the answer? Yes. So this is how you solve it. Yes, good. Many of them have done this. I'm happy to see that they have done. Okay, yes, nice. So this is how you do it. Okay, yes. Okay, next we'll move on to the next one. Is it okay now? Have you finished? Okay, yes. Okay, yes. So this is the another one. Consider an arithmetic progression with 2 and 101 as its first term and last term respectively. If the sum of first 5 terms of an arithmetic progression is 40, then find the sum of last 5 terms. Okay, Okay, you want me to show the last slide? Okay, this is what was the last slide. Okay, shall we continue with the next one? I think some of you have not on the camera, students. I think you were asked to do it. Then okay, yes. Then in case if you have a network problem, it's fine. Otherwise, it will be a problem, I think, later on. Okay, so shall we move on to the next one here? Here, what and all is given to us. So note down that A is 2. Okay, last term, see if it is left to you, you write it L or A and it's left to you. I'll just write it as L, which is 101. Okay, and then they have given S5 because sum of first 5 terms is 40, and then they are asking you to find the sum of last 5 terms. So how do you do it? Okay, very important. You know first what is S40, right? Okay. Okay, yes, that's fine. Okay, so now here let us continue. So how do you solve? First is S5, you know, right? So Sn is equal to, or S5 is equal to n by 2, that is 5 by 2, 2 into A is 2 plus 5 minus 1 into, we don't know what is D, right? So D is as it is. Then after that, we know here it is 40. So get this 2 here and 5 will be here. Okay, then here you have 4 into 4D. So here you get it as 8, right? Yes or no? 16. Then 16 minus 4 will be, this I'll get it here. 16 minus 4 will be 12. 12 is equal to 4D, or D is equal to 12 by 4. Answer is 3. Correct? Then after that, you know what else is known to you. You know what is the last term. Use an is equal to a plus n minus 1 into d. You know everything. Last term is 101. First term is 2. We don't know what is the last term's position. Okay, yes, Ketan, I'll just let you know the answer. Okay, yes, you will finish it off. You will understand what is the answer. Okay, n minus 1 into what is d? D is 3. Write down everything. So here, if you subtract 109, 1 minus 2, you get 99. Then get this 3 here, and then n minus 1 into this one. So you get here 33 plus this 1, if you get it here, plus 1 it is. So n is equal to 34. Correct? Yes or no? So now what is that you are asked to find? You are asked to find the sum of last 5 terms of this progression. Okay, n is 34. Yes. So what you can do is, you know now the progression is like this. 2, okay, common difference is 3, right? So the next term is 5, and so on. Last term is 101. So you are supposed to find the sum from last. There are 2 methods to do it. One is use S34 minus S29, because you need the sum of last term. In case you don't want to do it, then there is an option. What is that? Is you reverse this AP. If you reverse, you get 101 and so on up to 5, 2. Then D will be 2 minus 5. Answer is minus 3. N is 34 terms. Okay, you can do it. 1 minute. What is the doubt? 7th. How to do this? Yeah, that's what. Ketan, I'll be discussing those problems. I have left a bit of higher problems for later on. Okay, I mean, like concepts are little high. That's it. Okay, I'll be teaching everything. I usually don't leave only unless and until it is a very simple question. Okay, yes. So this AP progression chapter, every question I'll be discussing, because they are of different kinds. They didn't give much of basic problems. They have given little bit of higher level problems. Okay, yes. So now this is what we have. So next, once this is done, you know you have A has 101. Okay, now use Sn. Sn is equal to n by 2 into, okay, please understand, I need to find the sum of first 5 terms only. 5 terms only. That is why here n will be equal to, please understand, 34 are there, but this is the total term. Total term. But according to the answer according to our question, I need last 5 terms. But I have reversed the AP, so I need the sum of first 5 terms. So that is why use this 2a plus n minus 1 into d. So what is your answer? So one person is getting one answer, is it? So do that. N by 2, 2 into 101 plus n is nothing but it is 4 into minus 3. So do this. So what is your answer? You have to tell me. Okay, 475, 470, 499. What is it? Every person is giving me different answer. Okay, calculate properly, students. Okay. Okay, Navya has given one answer. Yes. Is it correct? Okay. So answer is it 475? Are you getting 475 as your answer? Check properly. Some of them are getting different answer. 1000 something and all I got, I've got here in the message. Okay, yes. 461. Okay, 470. Again, please check your calculation here. 101 into 2 will give you 202 minus 12. Okay, yes. It is 475. Yes, it is 475 is your answer. That's what I'm asking. Did you get 475 as an answer? If you have not got the answer as 475, please check your calculation because I've got here different answers. 460, 470, 4799 and all that. Okay, it will be 202 minus 12. Okay, yes, so you get 190 and then continue. Yes, 475. So all are getting 475. Shall we move on to the next problem? Okay, yes, that's it. Answer is 475. Okay, next question. I know you can't see this. I'll try to move it, students. Okay, yes, now at least you can see the question. Kindly note down the question. It is question number 9. Yeah, yes, Satvika, you can do that. It will be like little bit, okay, yes, that's fine. Okay, as I said, see, there are different methods to solve it. That's fine. Okay. So this is another question. A by B, AB and A minus B, A plus B. Above all shows real numbers. Okay, they are real numbers actually, but they have put them in terms of variables. That's what they have done. A by B, AB, A minus B, A plus B. Above all shows the real numbers that belong to an arithmetic progression in order. Okay, please understand it is in order. They are in AP. They have given their order of the some sequence. Okay, these are the part of that sequence, which is an AP. Find the next term of the AP. Okay, there is one request for previous slide. So I'll be just showing the previous slide for a minute, students. Please don't get confused. Okay, so this is where the previous slide is. I Fine. Yes. Okay. So this is the next one. What we have here. Okay. So shall we start with this? Okay. Yes. So first thing is they have given us this. Here there are three terms. Okay. A by B, AB, A minus B, and A plus B. These are in AP. Please understand, if they are in AP, okay, yes, they are in, okay, correct, A plus 3B, but you need to find, Navya, what is the exact value of that. So that is what we will be doing it today. So we'll see how we can do it. It's correct, whatever you have told me. Yes, you can proceed further with the solution. So what is that we do, try to do is, students, if you observe all of these, right, it's a very simple way to find the difference using these two terms. Because here if you observe, these are consecutive terms, correct? So using that, D will be equal to A plus B minus A minus B, correct? So you will get it as A plus B minus A plus B, correct? So you will get D as, this one cancels here, D as 2B. Are you able to understand? This is what we get. First equation, okay? And then after that, okay, using this we can have some equations. What is that equations is here, okay, one more equation we can form. This I'll take later in the later stage. First I'll take these two because they are much simple compared to the other two. So if you do that, it will be A minus B minus AB. Okay, first following term minus the preceding term. It is like that. Okay, this will be also equal to 2b. Why? This is next term minus previous term. It will be equal to the common difference. Okay, yes. Check it properly, Shashank. It is the next term minus the preceding term. According to that, your answer should be 2b, right? Okay, yes. So this is what we have. So then here, if you observe, I can just shift this B to the RHS. Then I'll get it as, please understand, okay, A minus AB is equal to 2B plus B will be 3B. And take A common, you get it as 1 minus B is equal to 3B. Okay, or A is equal to 3B by 1 minus B. This is what we have. If you want, you can name it as equation 2. Fine. This is what we have from the second equation. Now, let us go for the first one. Now, you may ask me, why am I taking only the common differences? If you observe, I have two unknowns which I can't solve without two equations, correct? Here, I just found what is the common difference. Now, what am I trying to do is, I am trying to find two equations. So, I got one using this. So, one, I used this to find the common difference. Next, I used these two to find the one equation. Next, I'll be using these two to find the another equation. Yes, simultaneous equation. That is what I'm trying to do because I don't have any other choice other than solving it and getting the value of A and B. I have two unknowns. I need two equations. That's why I'm trying to do this. Okay. So next, again, here I'll be using these two. According to that, it will be AB minus A by B is again equal to 2B. This is the common difference because next term minus previous term. Okay. Yes, Anika, it is correct. But you need to find what is the exact, even Anvita, exact answer for A plus 3B. Okay, so once this is done, the next step is you take A common. Then you will remain with here. Please understand, I'm taking LCM as well as I'm taking A common. Then according to that LCM, it will be B square minus 1 because A is common outside divided by B is equal to 2B. But from equation 2, what is A? A is 3B by 1 minus B. It's a substitution method I'm using. Okay, and this is here. 1 minute. Okay, here this says substituted using equation 2. Okay, from equation 2, and this one here is in the form A square minus B square. Okay, it is in that form. So I'll be using these two things here to solve it. So if I use that, then here it will become b plus 1, okay, into b minus 1 divided by b is equal to, this will be 2b, correct? Yes. So here, understand, this is 1 minus b and this is b minus 1. So if I want here, okay, here, if I want, 1 minute, no, just for you to remember, students, that's why I'm using different colors here. So in order to cancel these two, what I'll do is I'll take minus common and then I'll write it as 1 minus b. You have learned this in the previous chapter. You remember, right? Whenever I want minus common, it happens like this. It changes, right? Okay, so that is what we get. And then using that, in color, let me change. Okay, red. So using that, here I can cancel this and this. And then what you get here? This cancels, correct? Yes or no? Okay, yes. So then you will remain with this minus, okay, minus 3. And then this 2 comes here, b plus 1 is there. Please understand that is not cancelled, okay, is equal to 2b. Is it correct? This is what you get. Then go for minus 3b minus 3 is equal to 2b. This is what you get. Yes, correct. So shift this here and this you get it here. So you get the answer as minus 3b minus 2b is equal to 3, or minus 5b is equal to 3, or b is equal to minus 3 by 5. Is it correct? Are you getting minus 3 by 5? Yes, some of you have got 3 by 2 and all that. Okay, once this is done, again go back to equation 2. So by 2, you get a is equal to 3 into minus 3 by 5 and 1 by minus 3 by 5, and calculate and tell me what is the answer. Minus 9 by 8, is it? Okay, let me tell you what is the answer there. Okay, minus, okay, yes, minus, yes, correct. Minus 9 by 8, yes. How is it minus 3? Because I am multiplying, there is a minus sign here. When I multiply to both here, okay, it will become minus 3 here. That is how we get. Okay, yes, correct. This is minus 9 by 8. This is what you have, correct. Okay, once you get this, then last one is pending. That is, find the next term of the sequence. Whenever you have to find the next term, you know, last term is what? A plus B. In order to find next term, what you need? So next term is nothing but it is A plus B plus the common difference. What is common difference? 2B. So you get it as A plus 3B. So now A plus 3B you have to find using A and B. Find out. Okay, you want me to calculate? Okay, then I'll do it. I'll just erase the first part of it. Is it okay if I erase this part? Because you have finished this long back, right? Okay, I'll erase this part and then I'll do it. Okay, yes. So once that is done, A plus 3B, A is what? A is minus 9 by 8 into minus, oh, I'm sorry, this is not into, this is plus. Okay, yes. So minus, first 3, then minus 3 by 5. This is what you have. Minus 9, minus 9. This is by 8. This is by this one. It is 40, right? Okay, yes. So what you get here? Minus 45 minus 72. So add this. Whatever answer you get is correct. Yes. Yes. You get 117, right? Not 115. Yes. Saujanya, it is like, see, in order to find the next term in an AP, it is enough if you add the common difference directly. Common difference. That's wow. Okay. Yes. Yes. You can go for even the approximation using, calculator. I mean, like decimal, but it's better if you leave just, minus 117 by 40. That's more than enough for you to get the marks. That's enough because you don't have calculator to approximate it. In case in PU level, you have a simple calculator, go for it. At least go for minimum 4 digits after decimal point. Okay. Yes. So that's all you have. So this is what you have. Okay. Yes. Okay, yes. So I had done that, yes. Okay, next we'll move on to the next geometric progression. So next again, we will be coming back to the next one more progression, that is nothing but the geometric progression. Okay, so that's where I'll be ending with the arithmetic progression. I've just see one thing I'm telling you students here. I've not left the arithmetic progression. I've discussed only the very basic concepts and few what we can say average level problems. Okay, I've not done the advanced level problems. Advanced level problems are there. I'm just keeping it towards the end so that I can just finish the basic concepts. Once again, I'm telling you, please don't get confused. So I'm going to stop with the applications of the arithmetic progression. Now we'll move on to the next progression, which is a geometric progression. Now please try to understand. Okay, here this geometric progression, actually it has been developed mostly in different places. It is like, there is a, they are actually finding, convergent geometric series and all that kind of discussion was done long back. That is around 6th century. It was done around in Pythagoras, that, okay, that age it was done, BCE. That time it started, they discussed about the convergent series and geometric series and all that. Then it was discussed by the, Bernoulli's. There are two people, that is John, and then you have Jacob. Then you have one more person who discussed all these things. Okay, yes. So all this, actually Amit, we have a application of real life. I showed you few examples of arithmetic progression, right? How do we real in real life? We don't realize actually we are using the arithmetic progression there, to be frank. Actually we are using arithmetic progression in many of our real life questions, life problems, but we don't realize it that we are using that concept. Okay, so now that is about the geometric progression. And also it has been discussed even in India long back. One person of India is also called as the father of progression. I just want you to find out who is called the, the father of progression in India. In India, okay, just try to find out. Okay, so that's it. Mithul, I'll be answering your question later. Okay, just keep it pending. So this is okay. Oh, almost 5 minutes are there. Let me finish quickly the concepts here, students. Let me give you introduction. So here, when we talk about the geometric sequence, it is about the common ratio. Just like you have, in AP, the common difference. Here, the ratio remains the same. Okay, it remains the same. Okay, yes. Okay, Nidhi. Let us discuss the answer to that question later. Let me see how many of them will get. Okay. So some of them are saying, like, I'm getting different answers. So just find out exactly who is called like that. Okay. So there is some person who is called as, a father of progression, who has discussed lot of progression related concepts in his books also. Okay, Pratyusha. Yes, just find out which is that book he has used to discuss about it. Okay, yes. So just okay, yes. So that's I just want you to verify, because I got answers, two answers, Madhava and the Brahmagupta. I want you to verify who is exactly called as father of progression. Okay, and in his which book he has discussed about all those things. Okay, so that's why just confirm it. Okay, yes. Now two people are arguing. It is sure that it is Brahmagupta, and one person is saying, I'm 100% sure it is the Madhava. Okay, let us see who is correct. Okay, we'll discuss that tomorrow. Let others also get the chance. Okay. So now let us come back to this. Here, the geometric sequence. When we talk about the geometric sequence, here, the ratio between the consecutive terms remains the same. I had already given you those examples, right? I had given you other day like this, 2. Suppose you have 2 here, and then you may have 4, then 8, then 16, 32, 64. If you observe this, I'm just giving you a very simple example. There may be fractions. Okay, we will solve problems with the fractions. There need not be, okay, yes, yes. There need not be any problem regarding fractions. There may be fractions. It is possible, 100%. Okay. So here, if you find out the ratio, it will be like this: 4 by 2, 8 by 4, and 16 by 8, and then 32 by 16, and 64 by 32. All here, all these ratios, they will be same. That is why this ratio is called as the common ratio, and it is denoted using the letter R. Okay, it is denoted using the letter R. So now, suppose if you have same progression and you know here R is 2. Okay, then I can have the first term is always A. I have told you in the progression, the first term is always the this one denoted using A or A1, or in some books they denote it as T1. Okay, it just depends what book you are referring. Okay, I have given some of the reference books. I don't know how many of you have really seen it. There are those books are available in your this one. Okay, yes, just find out those books are available in the library, CFL library. You can always refer. Okay, now let us come back to this. Now, if you observe this 2 here, okay, if you observe 2, okay, yes, Shashank and Ketan, I have got a few answers from you. I'll just look into that. Okay, just let me finish this. So here I can write this 4 as 2 into 2. It's possible. And this also I can write it as 2 into 2 into 2. And same here, this also can be written as 2 into 2 into 2 into 2, like this 4 times. So what I do is here I try to write all the other terms in the given sequence using R and the first term A. So what I can do in that case is it will be like this. In the second case, it will become AR. That is A is 2 and R is there once. Okay, next after that, here it will be again A. I will not write A square because first term remains the same. And after that, it will be either the common difference goes on increasing or the common ratio goes on increasing. So here it will be nothing but R square it will be. Again continue this. This will be A and then there are 3 R's. So it will be R cube. Now please understand, this is the first term, this is the second term, this is the third term, fourth term, and then fifth term also continues like that. And if you observe, first term is A, second term is AR, third term is AR square, fourth term is AR cube. So according to this, if I continue up to nth term, okay, please understand, if I continue up to nth term, see, first term has no R, second term has only one R. So according to that, the nth term will be A will remain as it is, but R, power of R will be 1 less than the position. If it is nth position, it will be n minus 1. If it is rth position or the xth position, it will be x minus 1 or r minus 1, depending on what kind of position you have taken or what variable you have taken. It is like this. So this an is equal to ar minus 1 is called as the nth term of the given progression, that is GP. Is it okay? Clear to you? Have you understood how you get the nth term? Okay. Yes. So now this is about the geometric progression, that is GP's general term. Okay. General form is this, that is here A. General form is A, AR, AR square, and so on up to AR n minus 1. This is called as general form of given GP. Okay. And where is the nth term? Nth term is AN. Again, it is left to you, whichever book you refer, according to that, AN or TN, AR n minus 1. So this is what is the formula we have. Okay. Yes. I hope you have noted down this. It is already there in the slide also, but derivation is not there. That's why I was just explaining. Okay. Yes. So shall we move on to the next slide? Okay. Yes. So here are the few examples. Okay, it's very simple examples. You can see I've left very well, almost 2 lines only for the each example. So here, what is the first 5 terms of the geometric sequence? Okay, if the first term is 2 and the ratio is this. So what we use that general form: AR square, AR cube, AR power 4. First 5 terms, right? First 5 terms. So we got that first 5 terms. A is 2. So 2 first. 2 into half. 2 into 2, 1 by 2 square. That is 1 by 4. 2 into 1 by 2 the whole cube. That is 1 by 8. So you get it like this, right? And then 2 into 1 by 64, right? Because it is 4, 1 by, yeah, sorry, not 64, it is 16, right? Yes or no? Correct? I'm sorry, it is not 8 square, it is 16. So now cancel everything. So your answer will be 2, 1, and then you have 1 by 2 and 1 by 4, 1 by 8, like this. It continues. So this is the answer. Is it fine? Okay, yes. So now they are asking what is the next question. What is the 10th term of the geometric progression? So you want to find 10th term. So AN is equal to ARN minus 1. So what is the first term? A is 1. R is, okay, how do you find R? In the AP, it is second term minus first term. In the GP, it is second term, that is 3 by 1. So answer is 3. So according to that, your answer will be 1 into 3 to the power 10. You want to find 10th term. N is 10, right? So you will have 10 minus 1. So your answer is 1 into 3 to the power 9 or 3 to the power 9. Answer is 19,683. Is it correct? Are you getting it? You can keep it here if you don't have calculator. 3 to the power 9. Okay, or else you can do it using calculator if you have calculator facility. Fine. Okay, next here, the last term, last question. If the second term of the geometrical series is 4, okay, so they have given second term A2. How do you write A2 according to this? It will be AR. So AR is 4. Second term is 4. And then fifth term A5, which is nothing but AR power 4, 5 minus 4. That is equal to 1 by 16. So now in order to find the R, what I do is here, I divide it. Okay. Amit, which one you want me to explain? Okay, second one. Okay, I'll just finish the third one and I'll come back to the second one. Okay, I'm in between the third problem, right? So I'll just do that. Now here, please understand here, A2 is given, right? Here second term is given. That is 4. So I have taken second term of arithmetic progression according to the general form is given by AR. How R? Because 2 minus 1. That is how I get 2 minus 1 is this. And then A5. AR 5 to the power 5 minus 1. 4 you get. So this is what you get. And then what I need to find? I need to find the 9th term. So what I'll do, I need to find first R. Okay, please understand, I need to find first R. Then you can easily find out what is the first term, all that. Okay, so here in order to find R, what I'll be doing is, I'll be dividing this A5 by A2. Because it becomes easy. It's a ratio, right? Ratio remains common there. Okay, so this is A5 is, I know that it is 1 by 16. Okay, but before that, please don't forget to I'll be dividing. So what I do here, it is AR power 4 by AR. This is 1 by 16. This is 4 by 1. Okay, if you don't understand, this will be easier for you. I put one extra 1. So you get it as 1 by 64. Correct? And then here R, A, everything gets cancelled. Okay, this is getting cancelled. So you get R cube is equal to 1 by 64 or r is equal to 1 by 4 you get, correct? R is equal to 1 by 4. Now, if you know r is equal to 1 by 4, you can find out what is a here using that. You know that ar is equal to 4, right? R is 1 by 4 is equal to 4. You get the answer as a is equal to 16. Correct? Now a is equal to 16, isn't it? Yes or no? You get a is equal to 16 using that. So now you find out what is the ninth term. Using which formula? Using this formula. How do you use? A n is equal to a r to the power n minus 1. Okay, yes. So this is how you do it. Now those who had a doubt here, see, they are asking what is the 10th term of the geometric progression. We have the formula to find the nth term as, okay, please understand, nth term as a n is equal to a r power n minus 1. Okay, yes, Mithul, I checked the answer. Okay, so using this we can calculate. So here n is 10 and r is 3, a is 1. Substitute everything, you will get what is the a 10th. Same way here also you need to find out a 9th. Okay, so you find out what is that, that will be your answer. Okay, yes, fine. So I think it's already 5:10, so I'll be stopping the class here. Thank you for your patience. Okay, yes, so 1 minute. Actually, yes, Anvita, I was busy with the certain things actually, so I didn't get any time to correct it. I'll do it and I'll just do it. Okay, now for today there is no home. Yes, I have few homeworks for you. That is from the workbook. I want you to solve first 4 questions from workbook. Okay, please see that you do it. Okay, is it fine? First 4 problems from the workbook is your homework. If you can't do anything, just leave it. We'll discuss the answers in the class itself because it becomes really easy. Okay, yes, thank you. Thank you for your patience, students, because it's already 5:10. Just take a quick break. Okay, thank you. Yes.
Hello guys, can you turn on your webcams? We'll get started. Sorry, the other batch took some time. So you might have gotten the news from the other batch. I have some gift for you. Yeah, one second. Have I messed up something? I am the host, right now. It's my class, right? This thing. It's my class, right? Just asking. Confused now. Zoom didn't get banned. Dude. Okay, I don't think it'll get banned. Let's see. It doesn't have any security flaws as of now. So yeah. 1 second. I'll rename myself. That might help. Yep, there you go. Yeah, your gift is here. 1 second. It will come in a moment. The DPP is here. Your gift. Okay. So, did you read long message when I might have missed it? Exam is postponed for a day, so there's a lag of a day. Okay, do not forget that. There's a delay of 1 day. Okay, roughly. It's coming on how many pages? 10 pages, Anvita. The DPP is 10 pages. No. Don't worry. It's very easy. Don't worry. I didn't see Mithil. I didn't see it. I saw your mail. I know there's a mail, but I didn't see it. Now, don't worry. It's very easy. Okay. So how is it going to go now? Okay. So here's the thing. Level 1 only you have to solve, not level 2. Level 2, it will go on for a long. So level 2 is only just few pages. So don't worry. Now, you'll have to submit level 1. That's one thing. Second, when do you want the deadline to be? The choice is yours, actually. It's either going to be Monday or Tuesday. Which one you want to take? Test is Tuesday. So one possibility is Tuesday evening or Monday. Which one do you prefer? Okay, Tuesday. Majority votes came for Tuesday. So we'll go with that. Okay. So Tuesday evening will be the submission. Okay. Sorry, whoever said Wednesday, I'm really sorry. Majority votes came for that. Or even if the majority votes came for Friday, how would you even know? Yeah. Now, anyways, the highest votes came for Tuesday, so I'm going with it. Okay. Anyways, one more detail I got to add. So there are a bunch of problems you'll have to solve. Okay, we'll get started. So listen up. There is something I skipped, kind of, okay, which I didn't deal with or give a lot of attention. Mithil will be outside if you send more messages. Okay, you'll clog the chat box. Now, this set of problems which I'm going to do right now, I'm going to show you. These are very easy. This is not really hard. By the way, these are very important. The DPP is not yet posted. I'll tell you what's going to happen. First of all, one more thing. Your test will be on Schoology. Your exam will be on Schoology on Tuesday, whereas your DPP will be on Google Forms. Is that fine? Second thing, you will be sent a mail. You will receive your Google form. You know what that means. It's going to be in the format how your exam was conducted, the DPP. Okay. And this time, Anish, yeah, you'll be outside then. Listen to this. So your DPP will be in that format, Google Forms format. Each of you will get a different question, slightly different question. You'll have to solve it. Shashank, can you mail that to me, whatever you sent? What the cat problem is, success past that cat news. I'll come to that towards the end, Shashank. Okay. Yeah. Just change the password of your account. Okay. DP will be on forms. So you'll be able to enter the values onto the forms about what you solved. Now, do you have to show me the solutions? You don't have to. Technically, you don't have to show me the solutions. But if you want some sort of assurance, you need to do that, because if in the Google Forms, if you get something wrong, and let's say some technical error happens and you lose it, you can always show your that sheet of paper where you solve the DPP. You don't have to solve the solutions and everything, just that DPP where you solve it. If you do the solutions well and good, but in the DPP, if you just write down the answers, at least that's important, that you write down on a sheet of paper, because that'll be a proof that you had actually solved it and done it. Now that one you'll be uploading it to Schoology under some assignment. You'll be uploading it to that. Is that fine? Yeah. The exam is going to be on Tuesday. That'll be on Schoology also. So these are the instructions. Yes. Now, when will we get the link? Today evening at 8 o'clock. Worst case scenario, night at 1 o'clock. Okay, if I finish coding by then. Depends. So it depends on my time. Always we end up, what do you say? I'll be awake till 4 o'clock sometimes, and there'll be one person will be awake mailing me even at 2 o'clock, 3 o'clock in the night. That'll be Keithan. Okay, some mail will come. Okay, so I'll be awake till then, possibly. Yeah, 1 second. What is it? There's no solution. No solution. So no solution. 1 second. Okay, Pratish is awake till 6. Awesome. There was no. So no solution for the rest. You don't write the solutions. Yeah. Is the DPP time based? No. The deadline is Tuesday evening. You have to submit by Tuesday evening. How many questions in the DPP you'll know? Yeah. Okay. 1 second. We have a situation now. 1 second. Should we send the methodology? You don't have to send. Now, electrical circuits. Look at the DPP. I'll show you the solution. Yeah, you're supposed to message me here. Pratisha, yeah. A little, I guess, probably, yeah. That's outside. Anyways, listen to this questions. Okay, these questions are important. It was a mistake of mine to show all the answers. I forgot to erase this. Okay, I am so stupid that I forgot to erase this part. Now, I'll edit it and upload later. That's a different story. Okay. Anyways, on that good note of mine, where I realized I forgot to edit. Here's something for you guys. Not realize it now. I knew about it. I knew about it like in the other batch only. Okay. But here's the thing. Listen to this. So I'm going to do a bunch of problems now, which are very, very important from the test point of view, as well as these are important for other reasons. Okay. 1 second. Is there a direct button to do? Yeah, I can't do this. Is there an option called erase? Nope, I can't see it. Okay. Anyways, we'll get started. How would test be on Schoology? It's been conducted. Other batches, it's always been on that only. Okay. So going ahead and doing this, give me a moment. Try to put it to OneNote somehow. Is it possible? Yes. Please reply. Can you opening and closing forms as and when we want to submit? Yeah, you can close and open the. Yeah, the test is going to be a quiz, a Schoology quiz. You've done quiz submissions, right? Yeah, that's what it's going to be like. Okay, so that is something you can do. So not a problem. You guys are familiar with that process. How many questions in this is not yet planned? I'll try to minimize it this time. There'll be less questions because last time you said you did not have time. So less questions this time. Okay. Now, yeah. You guys told. All objective or subjective? No. So many subjectives will be there, obviously. Subjectives are there. Yeah, it is time-based. Would level 2 questions be asked? Yes. Obviously, ask one level 2 question just to annoy one of you. Okay. Some of you. Yeah, we'll do this. One moment. Give me a moment. It'll take me some time to erase things. There's a lot of stuff here. Okay, where is it? Give me a moment. This is taking time unexpectedly. Okay, this is annoying. Okay, got it. Don't erase. One second. I'll have to erase. By the way, you can download the textbook. Magnetism textbook has been uploaded to Schoology, so please download it from there. Okay, please do that. I'm about to kill a bunch of numbers. You'll see the blood later. Okay, I'm killing a bunch of numbers right now. They're dying. RIP numbers. Yeah. See you soon. Die in peace. Once again, almost done. Some numbers are dying still. Gone. Gone. Is there a time limit for each question? No, that won't be there. Don't worry. That won't be there. It won't be a quiz of that format. I'll relax your time limit. Anaka is like she can hear voices. From my microphone, or is it yours in your head? Yeah. I can't hear anything now. Yeah, before there was something, I guess. Before there was. Now you can hear. It's weird. Okay, done, guys. The room is clear. I've murdered enough numbers. We can go back to solving problems. Okay. See, all the blood stains you can see now. Can you see the blood stains? Yeah, done. Now we'll get started. The first question is very easy. Everywhere we are taking 10 to the power. Oh, okay, Anaka, sorry. Sarcasm. Sorry, really sorry. Okay, yeah. That was so stupid. Okay. Yeah, now listen to this. Listen to this. We have a condition where you're given Ke this way, okay? Ke is given. The problem number one is a simple one. There are two charges. Can you tell me the answer for this? There are two charges. Pratisha knows the answer instantly. Everybody knows the answer instantly. Hey, at least give it some thought. In your Zoom camera, at least make a face of thinking, like as if you're thinking deeply in your head. Okay, make that face at least. Okay, yeah. So after a lot of deep thought, finally Shraddha has answered. Okay, the answer came very late. She has thought a lot over this, and we have the answer here. Okay, okay, listen to this. First of all, Coulomb's law. Stop it, guys. I know you know the answer. You've seen it. Papa. Yeah. Now listen to this. It's easy. You know the Coulomb's law, right? Force is equal to what is that? K times Q1 times Q2 by R square. What is the distance? Red. 2 square. Done. This is 4. This is Q1 is how much? 2. How much is this thing? 9 into 10 to the power 9. So how much is that? Yeah, how much is this? 18 into 10 to the power 9. Okay, 9 newtons. Is this fine, guys? Is this fine? 18 you have to calculate because I asked 10 to the power minus 9 multiplication. Okay, next one. Your numbers will be different, guys. The DPP. My numbers and your numbers are completely different. Okay, next one. Second one. Or let's see, let's resurrect one of the numbers. Resurrection. Done. It's back. Alive from the dead. 18 is back. Now tell me this one. This time I'm asking for the electric field. What's the electric field? E is equal to K times Q by R square itself. R square itself. So tell me how much is this? Yeah, how much is this? Okay, okay. So this is going to be 9 into 10 to the power 9 into Q, that is 4, divided by how much? R square. How much is that? 4 square. How much does that give you? Sorry, 4. Yeah, 4, 2 square, 2 square. How much does it give you? 9 into 10 to the power 9. Is that fine? So the answer is 9 for this. Yes. The magnitude of the electric field, which is nothing but Newton per Coulomb. Is that fine, guys? Can I get a yes or no on that? It's very easy, straightforward, based on what you had studied. Anvita, what did you say? Okay, okay. Is this fine, everyone? Okay, we'll go to the next one. Listen to this. Now there are some important things to be discussed. Now listen to this. Newton per Coulomb is a unit of electric field. Now, the next one is very, very, very important. Okay, listen to this carefully. You can't download the option, yeah, for the text. We have to view it online itself. Okay, now this is a tricky one. Okay, there is a concept which I had not explained to you guys and I skipped it. Now I didn't know that it was there in the textbook, so I kind of skipped over it and skimmed over it. Now this is a topic which is very, very important. I'm going to discuss it now. So listen carefully. Okay. How many of you heard of the concept of potential? Potential. You know potential difference. That's potential difference. This is just potential. I captain. Okay. Nice. So with that being said, I have a question now. Do you guys agree if I keep two positive charges next to each other, I'm storing some energy? Is there some energy stored there? If I let go, what happens? If I let go of the positive charges, what happens? Strong repulsive force, right? They'll fly off. Agree with this? There's some energy stored. It's like a rubber band. Do you agree if you had, in case, a positive and a negative charge very close to each other, do you agree there's a strong force between them? Attraction force between them? Can you pull them apart? If you pull them apart, do you agree you store some energy? If you pull them apart, you'll be storing some energy. Yeah. The idea is, the concept is something like this. If I have some charge Q, and let's say, no, listen to this carefully. So let's say I have some charge Q, and my subtitles is working right now. Let's just go with this. Pull them close. Yeah, now the idea is I'm going to take a charge Q, I'm going to take another 1 coulomb of charge, and I'm going to bring it from infinity to a distance of r. I'm going to bring it from infinity to a distance of r. Is that fine? From Q. Do you agree I have to do some work to do this? Do you agree that I have to do some work to achieve this? Why do I have to do some work? Tell me. Because I have to get it from infinity against the force of electrostatic repulsion, right? There's repulsive force, right? Agree with that? So I have to spend energy to get it there. Agree with that bit? Okay. If you agree with that bit, the question is, do you agree if I spend some energy, where is that energy stored then? Where's 0, 0? I didn't get that. Oh. To get this 1 coulomb, where is it stored? It's stored in the particle, or it is stored in the field, right? Agree with that? I can't say it's stored in the particle because it could be stored in the positive charge or also in that 1 coulomb charge which I got. It doesn't make sense. I would suggest it's stored in the fields. Is it fine? Is this fine, guys? Stored in the field, stored in the configuration. Now, if I let go of this charge, what happens? Tell me. Do you agree that energy will be released? Yeah. Now listen to this carefully. There is a definition word called electric potential. Okay. This is a concept. Now, it is defined as the work done in bringing 1 coulomb of charge, from infinity to a distance r. It is the work done in getting something from infinity to a distance r, getting 1 coulomb of charge from infinity to a distance r. It is given by the formula V is equal to K times Q, the charge which is there in this where you're bringing the charge to, divided by r, not r square. That's the only difference. We know what is infinite, really far. Infinite means really far. Is this fine? This is a formula for the potential V. This derivation involves integration. I can't do this derivation. It's very complicated and involves integration. V is electric potential. Yes, potential. This is equivalent of a gravitational acceleration, G m by r. Gravitational potential. Remember last year? Remember gravitational potential from last year? You had minus Gm by r. How many of you remember this? Can I get a yes or no on that? You remember? Yeah, it was there in the textbook. Derivations are hard to give you, but it's very hard. Yeah, I'll come to that, Satvika. That expression is there. It exists. There is a definition like that. Yes, it's related. You are right. You're right. Now, did you agree with this? Do you guys agree with this? Work done here will be positive, negative. Now, that's very important. I defined it as the work done by me in getting that 1 coulomb from infinity to there. Or there is one more definition of it. How much energy, oh God, how much energy is stored in the field. That matters. How much energy is stored in the field. Like, for example, when I did this work, how much energy was stored in the field? This much. Agree with this? Do you guys agree with this? Work done by me has to be stored somewhere. It's stored in the field. Whatever energy I spent should be stored in the field now. Agree with that? Is that part fine? Okay. 1 second. So work done by me in getting it from there to here should be positive. Agree with that? It should be positive. It's work done by me. So that's the definition of it. Now listen to this carefully. Okay, with this, listen to this carefully. I'll add one more thing. There are two ways to define this. One is that, and the other one is how much energy is stored in the field. Now listen to this carefully. Why this matters? Now, what if this was a negative charge? What if this was a negative charge or a positive charge? What would the formula become? Negative. Agree with that? If this was a negative charge, Q would have been minus. Agree with this? Is that fine? Yeah. So you would land up with a negative charge. You're getting 1 coulomb from infinity to a negative charge. Do you have to do any work? Would you end up doing any work? Or the field does the work? Who does the work? Tell me. Who does the work? Tell me in this case. The field does the work, right? Agree with this? If I were to get 1 coulomb of positive charge from infinity very close to a negative charge, if it is brought there, did you do any work? It's attractive potential, right? Both will attract themselves, right? Yeah, both will attract themselves. The positive 1 coulomb and the negative charge will attract themselves. Agree with that? Yeah, so do have to do any work. The field itself will, electric field itself will pull it closer, right? It won't, I don't have to work against the force. Is this part fine, guys? The definition of the potential says that the work done is bringing one, how much is the definition of electric potential is the work done in getting 1 coulomb of charge from infinity to a distance r in the presence of a charge q. Is that fine? Keaton, wait. I'll come to that. Is that part fine, everyone? No, that doesn't matter, Amit. Yeah. Okay. Now, this can also be defined. Now, when you look at it, if you bring one positive charge close to another one negative from infinity and hold it for a time t, what would be the total energy spent by you? Yeah, the total energy spent by me is given by this formula directly. Potential. It tells you that matters how close you get them. It matters how close you get them. That matters. What distance you get them. Okay, listen up. Some of you are still confused. Okay. I'm using up a space here. Let's say V is equal to K times Q by R. So if there is a charge, this is a positive charge, okay? Positive Q. If you get something from infinity to a point R, let's say to a distance of R, if you kept it there for a long time, nothing happens. You're not spending any energy. Theoretically, you're not spending any energy. If it stays there, if it's kept there, you won't be spending any energy. Okay. Now observe this. If I get it to R at this point, I'll be getting it from infinity to a distance of R. Then the energy spent by me so much. Is this part fine? No, field lines won't help. Field lines won't help here in this concept. It won't help. Is this fine? Can I get a yes or no on that, everyone? Just as a signaling tool. This is a very important idea. That's why. How are we getting to infinity? Let's say I get it from infinity. We are getting a 1 coulomb charge. For minus 1 coulomb charge, you get the same quantity as V is equal to minus K times Q by R, because it tells you, it gives you a negative value. The reason for that is the definition works. The work done by me is a negative now. It's no longer positive. Or one way of looking at it is, in this case, are you storing energy in the field? If you get a positive and negative charge, if there's a negative charge, if you're getting from infinity and placing it here, are you storing some energy? Are you even storing some energy? No, right? You're not storing any energy. When you think about it, you're actually not storing any energy. Yeah, it just happens. You're not storing energy. To pull them apart, you have to spend energy. To pull the positive and negative charge apart and take them to infinity, you have to spend energy. Is this fine? I can't. Pratisha. Yeah, is that fine? Yeah. Yeah. Okay, Marudha, we'll look at that. One sec. Okay. Now a few things. Okay, listen. Your work done concepts from last year are proper, not straight. Okay, need to straighten them. First of all, remember this example. Have I done this for you? You have to remind me. Okay, you have to remind me. This is volume 1. I don't know how many of you taught of volume 1. This is volume 1, 9th standard. I've taught you, Pratisha. Volume 1, sure. Work energy, have I taught you? Okay, answer me this. You're carrying a box. You're carrying a box. You're carrying a box from this end to that other end of the room. You're carrying it from one end of the room to the other. Is this fine? Okay. Now I have a question. If I'm carrying it from one point to the other, okay, Amit, cool. You're getting it from, let's say, some distance. You're taking it from this thing, some point to, let's say, another point in a gravitational field. Which direction is the force acting? Which direction is the force acting? The gravitational force acts downward, right? Agree with that? Gravitational force acts downward. The displacement is in this direction. Tell me what is F dot S? What is F dot S? How much is the work done? Force is 90 degrees to the displacement. What is the, wait, Ketan, yeah. I would say you're wrong and right. Once again. Is it 0? How many of you think it's 0? Yeah, so I have a question to you now. I have a question for you guys. If you were to take a box around, yes, Nidhi, that's important. Yeah. If you're taking a box from one corner of the room to the other, aren't you doing any work? Aren't you doing any work? If you're taking any box from one point of the room to the other, aren't you doing any work? Then how is the formula giving 0? This is a common example that's given and a common misconception that's created. Yeah. Okay. Listen to this. Listen to this carefully. Why did the box move? Yeah, I know. Why did the box move? Why did the box move in the first place? Because you applied a force, right? And in which direction was that force? Yeah, Satvik, you're right. Yes. In which direction was the force? In which direction did you apply a force to move that box? In the same direction as this displacement, right? Is this fine? So the work done by you is not 0, but work done by gravity is 0. Gravity did not do any work. If you think about it, gravity actually did not do any work. The box did not even fall down to the ground. Do you agree with this? So listen to this carefully. Both things matter. Work done by whom? Okay, Anika, I'm getting it. Work done by whom matters, and on what you're doing the work. Both things matter. Okay, by whom the work was done and what object. Both of them matter. Yeah, Anmita, I received it just now. Yeah. Okay. Now, listen to this. Listen to this. This is important. What is 7sV? I didn't get that. Okay. Anyways, so I have a question to you now. If I were to place a positive charge here, okay, Q, and I'm getting some 1 coulomb of charge from infinity, let's say, a coulomb of charge. V is electric potential. That's the definition of it. Okay. Okay, Sakshi has a continuity. I'll stay on this topic, okay, because this is, I need to clarify. The question is, if you get tired and lower the box, hasn't gravity done some work? What do you guys think? If I lower the box to the ground, has gravity done any work? Think carefully and tell me. If you drop it, yes, I understand. If you drop the box, yes, gravity seems to have done some work. Okay, tell me, if you hold a box in the hand, are you doing any work? If you just hold the box, no displacement. Hold the box in your hand, are you doing any work? What is work done, by the way? What is work done? What is work done? A, no, F into S. What is it? Energy converted from one form to the other. Agree with that? Agree with that? Okay. Now, do you see some energy is getting converted here from your muscles to your muscles? You're sweating, you're spending some energy. Energy is getting converted somewhere, something is changing. Yeah. So work is being done by you. How is F into S 0 then? When you're holding a box in your hand, how is the work done 0? Just holding it. You're not doing anything. Not even gravity is pulling it, nothing is happening. But you're just holding the box. How is it that the work done by you is 0? Displacement is 0, doesn't matter. Energy is being converted. I can see that energy is getting converted. You can't say there is no displacement. My question is very simple. If I'm holding a box in my hand and standing, I get tired after some time. I am spending energy. My muscles are wearing out. Energy is getting converted to some other form. Somewhere energy is being used. F into S is giving you 0, but still. Then why is energy being spent? Where is work being done then? If energy is getting converted? No, no. I told you 2 words earlier. I gave you 2 words. Work done. Wait, Mithul. You sent a lot of messages and others. I didn't receive anybody else's messages in the last 1 minute. 1 second. Don't send messages, guys. It's clogged right now. To store, no, not to store. You're spending energy but not doing work. Okay, how is it possible, Vivek? You're spending energy but not doing work. Energy has to be converted, right? Energy is used in holding the box. Okay, how is that possible? How is that going to help? But work done is 0, it says, right? If energy is used, there must be some work done. Okay, 1 second. Mithul, you're wrong, not right completely. Force is not in the direction of the displacement, but in fact, there is no displacement at all, 0 displacement. No, not against the ground. It's being converted into potential energy, no. 1 second, guys. Work is done to prevent the object from falling to the ground. So, how would okay, work is being done. Okay, cool. Work is being done. Then why does work done become 0? Then why does it show that work done is 0? No, it's not. It's stored in potential energy. 1 second. You have to stop your messages. Being converted into, no, it's not converted. Anvita, yes, you're right. Sorry for the length time taken to answer that. Yeah, Sathik also is saying energy is used to prevent the box from falling by the earth. But then why is F into S 0? Why is F into S 0? Why is the displacement 0? You're spending energy to make sure it doesn't move in the opposite direction. But still, hey, displacement is 0. The work done should be 0, right? Yeah, Sumedh, you're right, but your answer is not complete. But work done is 0, Sumedh. I told you F into S is 0. How is that possible then? Whatever you said is done, right? But it's easy. Listen, Sumedh said something simple. He was like, my muscles are converting energy to heat. Okay. So work is being done that way. But I'm saying work done, we're getting 0, right? We're getting work done as 0, right? Mithul, 1 second. You're sending a lot of messages. I'll have to skip your messages then. No, Mithul, wrong. Work is done by gravity. Work is not done by gravity also. Gravity is also not pulling the box down. Nothing is happening. You guys are right. You guys are almost there actually, some of you. But it's not got to do with gravity. It's nothing to do with that. It had to do with your heat and muscles part. But you have to extend it and explain why. You're right about that one fact. But you have to explain why is the work done 0. Why is the work done 0? Remember, I told you 2 things in the beginning. There are 2 parts to work done. First one is the agency which does the work. Second part is the object. You need to answer both of them. My question is not very clear. That's why the confusion. Okay. I want you to understand and clarify me based on those 2 points. There is no displacement in the object. I agree with that. So work is not done. Then how is it I'm spending energy? I'm just trying to clarify your chapter last year. These are the fringe problems where your work done concepts become stronger if you understand these concepts really well. If you can answer these questions which I'm throwing at you right now, your concepts will become very strong with work, energy. We have to take it to a height and raise displacement. Yeah, but yeah, Murali is saying you're doing work to prevent the conversion of potential to kinetic. Wait, that doesn't make sense. You're spending energy, which means where is that energy going then? If you're spending energy, if you're preventing something like that. Gravity is not doing work, not doing any work. I understand. Okay. So there's one lead here. Gravity is not doing any work. Rule out that possibility. Gravity is not doing any work. Is your body doing any work on the box? Is your body doing any work on the box? Is body applying a force and doing anything on the box? Okay, who sent that? 1 second. Okay, 1 second. We'll have to kick someone out. Give me a moment. One second. Ashay, thou shall go out. Bye-bye. Yeah. Now going ahead once again. I missed a lot of the messages. Thanks to Ashay. Okay, a lot of them. Half of them, in fact. Preventing it from the force might be equal to the box. Okay. Oh, there's no waiting room. I'm sorry. Not there. Okay. You're preventing it from that might force the. Okay. Your muscles are converting ATP to this thing. Yeah. To ensure the box remains at the same potential. Okay. Energy is used to keep the boxes up and or heat, but the displacement doesn't. Yeah, displacement. There's no work done. Yeah, if work is not done, how is energy being released? How is my body losing energy? Yes, now we answered it. Now we are the first one to answer it properly with one line. Now we said the following: we do work on ourselves, not on the box. Work is done, not on the box. I was trying to refer to you one more property, right? That the box matters, object matters. Where are we doing work? That's what I was getting at. The point I was trying to get at is both the things matter. On what you're doing work, you simply can't say work done. Okay, what you're doing work on. Second thing matters is the agency, who's doing the work. That determines the sign usually. Is that part fine? One second. I have to scroll. I missed many of your messages because some people are sending 3 times certain things, 3-4 times. 1 second. Yeah, even Nihat said the same thing, I guess. Work is not done on the object. Yeah. So listen to this carefully. There's a concept. This is important. When you say work done, you got to answer 2 questions. Work done. You have to tell what is the object you're doing work on. You can't simply use the word work is done. You have to tell who is doing it, the agency. Both the things matter. Is this part fine? No. That is not the answer. That's not right. Okay. Now, with this being said, understand it now. If I carry a box and keep it on the ground, as Sakshi said, in this case, what happens? Are you doing any work? If I take a box and place it on the ground, are you doing any work? Yeah, maybe, Shashank. That's the same answer others also told. Yeah. But that's not the answer. That's right, but it's not the answer. Who is doing the work in taking the box to the ground? Are you doing any work? See, your body is doing some work. Your body is in fact keeping you alive by doing work. It's doing work continuously. Okay, it moves your muscles and all this stuff. There is some conversion energy happening there. Yes, that is true. But when you lowered the box and placed it to the ground, who did the work? Agree, gravity did the work. Did you have to spend some energy? I don't think you really have to spend some energy. Is that part fine? When you let the box go to the ground, you let gravity do some work. Yeah, I know, Shashank. I was talking about you, Shashank. Is that fine? So it is positive. Now, work done by gravity is positive. Is that fine? Part fine? Part fine? Oh my God. Did I say fart? Okay. Listen to this. When you're tired and you keep saying, yeah, it goes on. Listen to this. How are we doing work on ourselves? You're not doing any work on yourself exactly. Your body is doing some work in converting the stored energy into some form of heat energy in the muscles. Okay. So when I use the word work done, I didn't specify the object. Remember, I told you work is being done. Your body is losing energy. Your body was losing energy because your body was doing work. Displacement is in your muscles. Displacement is in those tiny atoms where the energy got converted. The chemical reactions are happening. It need not have been in the form of displacement itself. Work can be done in other ways also. I would say that some form of chemical reaction occurred, and those displacement contributed to this thing, energy. It was on a micro scale, the energy lost there. Yeah, the force was the muscular forces, the atomic, the forces which keep your, look, if you don't, listen, what happens if your muscles don't apply force, what will happen in your body? Don't get contracted or pulled. Tell me, what happens? You'll fall, right, to the ground. You'll be like a jelly, almost, falling to the ground with no strength or nothing. Yeah, floppy, flappy, or whatever. That's the word. Yeah. Agree with that? Yeah. Now the direction matters. I understand. Directions matter. In which direction? Now direction part is a little bit tricky because direction could be. We don't have to actually care about the direction in that case because it's much more complicated. It's happening on the atomic scale, right? So we can assume it's in the direction of the force. It's actually in the direction of the force. These displacements, what we're talking about. But I want to make a very important point here that this equation, one second, this equation, F into S, F into F dot S, is an equation of classical mechanics. It's for classical forces with displacement, real objects and stuff like that. Later, it was extended to capture many other quantities, let's say fields, energy stored in fields and all that stuff. Okay, so this was an energy of movement, energy caused by movement. The other was the energy caused by configuration, stored in the configuration. Okay, need not be, listen, displacement need not be always in the direction of the force. Displacement can be at 90 degrees or 30 degrees also, that's fine. Still work is done. Okay, work always, force need not be always in the direction of this thing. Work is done irrespective of whether it's in the direction or not. Okay, listen to this last one. Answer me. This is one question I asked about to clarify about work and displacement. Answer me this. You have a lift. You have a fridge, let's say. Okay, Muralidhar has a fridge. He lifts the fridge and pushes it. Wait a second. What happens is, okay, let's say this happens. I'll draw it. I need to draw it. Actually, I had a visualization in the last year's PPT, but this is fine. I'm going to draw it. Muralidhar has a fridge, Super Murali. Okay, Muralidhar is strong enough to push a fridge. Okay, now Muralidhar starts applying a force to push the fridge, but the fridge falls down like this, goes like this. What is the work done by him? Displacement is this. Murali applies a force like this. For some reason, the object goes downward. What is the work done by Murali on the fridge? Listen to the question. What is the work done by Murali on the fridge? Yeah, I'll come to that. Zero, agree with that? By definition, it is zero. F into S is zero. So my statement is not wrong. Work done by Murali on the fridge is zero. Now tell me, who actually did the work? Do you think there was one more force at work? Yeah, there must be other force. Maybe gravity did the work. Otherwise, the fridge wouldn't fall down, right? You guys got it? So the work done by gravity is not zero. Gravitational force is almost in that same direction, probably. Yeah. Is this fine? Anvita is like Papa Murali. Okay, fine. Is this fine? Yeah. Yeah, sure, Murali Baba. Yeah, fine. Now, going there, here we go. Here's some important things. Okay. Yeah. Okay. Fine. So if you understand these concepts, it's useful. Okay. One last thing. Okay, Murali this time, for some reason, applies a force on the fridge here, or we'll give him a chicken, okay, this time. Let it be. Some chicken, okay? I can't draw chickens, wait. Okay, let's take Murali only and apply, oh, can't, that is too bad. We'll take a chicken only. And Murali applies a force, F like this. Chicken goes downward for some reason. Chicken doesn't go up. Chicken has a problem. Why? Why does, like, what is the work done by Murali? Tell me. What is the work done by Murali? Let's say force was, he applies 10 newtons of force, but chicken goes down with the displacement of 3 meters. How much is the work done by Murali? How much was the work done by Murali? How much was the work done by the force applied by Murali? Listen to this carefully. Murali is like zero. Murali is a hero. He only saying that. Okay. Anyways. Okay. Actually, we go by this logic. We say the work done by Murali was actually because he applied the force on the object. He tried to apply force on the object. He did apply force on the object, but it's just that nothing happened. Okay, he tried to do something, but then it didn't work. So by definition, we go and say we say it something like this: the work done by Murali is actually minus 30 joules. Now the reason why we say that, and I'll tell you, listen to this. Let's say gravitational force was much stronger than Murali. Gravitational force was like, I'll apply 20 newtons. If Murali applies 10 newtons, I am better. I'll apply 20 newtons. Okay, that's what happened there, let's say. Now tell me, which direction will the chicken move? Do you agree the chicken will go downward? Do you agree that chicken actually will end up going 3 meters downward? Now, if the chicken went 3 meters downward, now if I ask you a question, how much work was done by Murali? Murali tried doing some work actually. He did put some effort. Okay, against the gravitational force. Okay, against the gravitational force, he applied some force, right? Agree with that? So how much is the work done by Murali? Tell me. Minus 30. Agree with this? We get it as minus 30. Is this part fine? We'll have a chicken fight in the end towards the end. Is this part fine? Yeah, Nidhi, I'm getting there. I'm actually going there, okay, to this concept. Now, I'll tell you why we say that. I'll tell you why we say that. You'll understand now. Tell me, what is the work done by gravity? Can anyone tell me what is the work done by gravity? What was the work done by gravity? So Murali lost 30 joules. Agree with that? We say Murali lost 30 joules, kind of. Or we are saying Murali did not, what is it? We say minus 30. How much is the work done by gravity? 60. Agree with that? 60 joules. Okay. What is the net force on the object? What is the net force on the object? Tell me. What is the net force? What is the net force on the object? Look, 20 newtons downward, 10 newtons upward. What is the net force? Agree with this? 10 newtons was the net force. Agree with this? 10 newtons was the net force. Both forces get cancelled each other. Now, how much is the energy actually stored in it? Resultant force is 10. How much is the force that acted on it actually? 10 into 3. Agree with this? 30 joules only. So I'm telling you a simple question now. Gravity spent 60 joules. Murali actually ended up applying 30 joules. In the end, how much does this thing have? How much does the object have inside it? How much energy is stored in the object now? 30 joules. Agree with this? Now, if that's the case, do you agree Murali should have spent minus 30 joules? Murali should have spent minus 30 joules. Otherwise, this is not possible. If you want gravity to apply 60 joules, spend 60 joules of energy, and Murali to spend the object finally ends up with 30 joules. 60 because 20 into 3. Gravitational force was 20. 3 was the displacement step. Okay, this wasn't a great page to draw things. So 1 second, untitled page. Listen to this. Buying new real estate. Observe this. Let's say we have Murali here applying a force on an object. Okay. Now this is gravitational force which acts a force on the chicken in this direction. Okay, Fg. Now gravitational force is roughly about. Listen to this. Gravitational force is roughly about. I'll take different values. Okay, because that was hard one. I take it at 40. Okay, 40 newtons. Murali applies a small force of 10 newtons. Is that part fine, everyone? Okay. Now listen to this. We ask ourselves, how much is the total work done, listen to this, total work done on the object. Is this part fine? What is the total work done on the object? Now we have information under these forces, two forces, the chicken happens to move a distance of, let's say, 2 meters. Is this fine? Is this fine? Okay. Now we ask ourselves some questions. Okay. How much is the work done by the gravitational force? How much is the work done by the gravitational force? Fg into displacement. How much is that? 80 joules. Is this part fine? Okay. How much is the final resulting force on the object? Resulting force. Thanks to Murali and both of them. How much is the resulting force? Resulting force is how much? 30 newtons downward. Agree with that? 30 newtons downward is the resulting force. So how much force acts on the object if I say it's just 30 newtons? Is this part fine? Yeah? Is this part fine? It's just 30 newtons. What's acting on Murali is just 30 newtons. Is this part fine? Okay. Now, how much is the displacement of the object? 2 meters. So how much is the energy? How much is the work done on the chicken? Tell me, how much is the work done on the chicken actually? Totally, how much work was done on the chicken? 60 joules. Agree with that? 60 joules. Now I have a question. If gravity did 80 joules of work, gravity ended up doing 80 joules of work, okay? And this thing, what is that? The chicken ended up having gained the energy of 60 joules. Murali should have spent some energy, right? Murali should have, how much should be Murali's expenditure then? Minus 20 joules. Agree with this? So work done by Murali, we say is minus 20 joules. Is this part fine?
Yeah.
I'm just clarifying the words. Work done by Murali. Work done by gravity is 80. What is the total work done on the object? 60. Is this part fine? Yeah. Yeah, we're using F dot S, but the point is we need to clarify who's doing how much work. And that's where the negative sign comes into being. Is it fine? I'm sorry, I took some time there. It was just a detour. It was not that important. Okay. Ashay, it was not that important. Don't worry. Okay. Yeah. Even Nihal, it's fine. It's totally fine. But we'll discuss that towards the end. Just remind me. Okay. Now, going back to my topic, which I was discussing. Listen, I'll finish this and we're done. Don't worry. I'll just finish this one topic. Okay. One question. Listen to this. So what I'm going to do is I'm going to get something from infinity and bring it to a distance of 2 meters. I'm going to get something from infinity to a distance of 2 meters. How much is the potential? Oh my God, I'm showing the answers. What a stupid person I am. Okay, one second. I didn't see that. I was on the wrong thing. Okay. How stupid can I be? Now tell me, think a lot and tell. Do that thinking phase of yours. Think deeply and tell me how much is the electrostatic field potential at this point when I get something from infinity to a distance of 2 meters. Nice, Varun, you thought deeply. Now you got it. Nice. I understood. Keaton, yeah, I know. Brilliant. Yeah, Saujanya, awesome. Better, smarter. Okay. Now I have a question. I'll do the method. Listen to this. What is the work done in getting something from infinity? So electric potential, field potential at that point, at distance of 2 meters is going to be V is equal to K is 9 point, this thing into 10 to the power 9 into how much is the charge? 16 coulombs that's been given, divided by how much is the distance? 2. So that's going to give you how much? 72 into 10 to the power 9, right? Is this fine? Is this fine, guys? Yeah. Now listen to this carefully. I'm going to use a different unit. And by the way, this is the work done per coulomb, right? But the unit of voltage, you know, it's nothing but work done per coulomb. 1 coulomb. Agree with that? Yeah, fine, Marudha. So this is going to be of the unit of volts. Is this part fine? Or joules per that 1 coulomb. Number of joules. The unit is going to be joules per coulomb. Is this part fine, everyone? Now, basically what I'm saying is, I'm trying to calculate how much is the potential at 2 meters, electric field potential from a charge Q. Is this fine? Does it make sense? Okay, this basically means, understand this, okay, listen to this. This basically means, if you were to get something from infinity to a distance of 2 meters, then you will have to spend 9 into 10 to the power, how much? Sorry, 70 into 10 to the power 9 joules of energy for 1 coulomb. That's a lot, right? That's a lot of joules of energy. Is that fine? So that's the potential at that point. Just that's it. You just need to know that what's the potential at that point. What is the potential? What is the electric field potential at 4 meters, at a distance of 4 meters? Yeah, this energy is stored in the electron, they might say, or stored in the field. This energy that I contributed, 72 joules, 72. Okay, I'm going to use a different unit, okay, from now on. You guys are going to be comfortable with this, right? I'm going to use 72. I'm going to use a unit called 72 gigajoules per coulomb, or I'll use 72 gigavolts. Is this part fine? 72 gigavolts. That's going to be my unit for this problem. Okay, what is the potential at this thing? You guys did the calculation, right? 9 into 10 to the power 9. Everyone. Giga means 10 to the power 9. Into, I'm using the formula V is equal to K times Q by R square. R, yeah, 36, right? So it's going to be 36 gigavolts. Okay, gigavolts. Yeah, it's in the system. Why I'm saying, so listen up. There was a doubt, okay? Is the energy stored in the 1 coulomb of charge that I brought from infinity? That's the question. Is it stored in that 1 coulomb of charge? Can I get a, how many of you think it's stored in the charge? Ignore that giga part, okay? Just you can skip that. Don't worry. You can just simply use, instead of using this unit, you can simply use, if you're not comfortable, use this one, 10 to the power 9 into joules per coulomb. That's also possible. Or volts, 10 to the power 9 volts. I'm using giga because giga means 10 to the power 9, GB, your gigabytes. Okay. How many of you think it's stored in the one coulomb charge? I would say it's stored in the field. You know why? Because there are two electrons involved. There are two electrons involved. If you say one electron, what about the other electron? You might ask. How does the other electron not get the energy? You got the logic, right? I could have gotten the other electron from infinity and brought it, right? The plus Q charge also could have been got from infinity and brought it there. Agree with this? You guys got it? That's why we see energy stored in the field, not inside the electrons. Potential energy is not stored in the object, it's stored in the field surrounding it. Okay. Didn't get that. I'm really sorry. 1 second. Yeah. No, you don't need to know those details, but this is important. This part is very important. Listen to this. So it says that the voltage formula is this. So I'm asking you, what is the voltage at a distance of R from this charge? Okay. Yeah, we talk about the potential of the field generally. Yeah, potential energy is the energy stored in the configuration or in the field. If you leave the electrons, they will if they are the same charge, then will the electrons accelerate in opposite directions? Yes, both of them will accelerate. If you unless you fix one of the electrons, both of them will accelerate instantly the moment you apply a force. Hope that's fine. It's logical. Yeah. So in electrostatics, what we're assuming is we have fixed one of the charges, and we're getting other charges from infinity to the point, and we're doing some work, and we're storing that energy in the field. Okay. Now listen to this. So the field here is how much we got the value as 30. How much was it? First one. Everyone, tell me quickly. I messed up. 72. 72. Okay, I can reveal the answer. 72. Nice. Oh, I resurrected a number. Yeah. Next one. This one was 36, if you remember. And the last one is how much? 18. Okay. It's 18. Yes. Now, I have a question. Let there be a charge of 1 coulomb. I place, let's say not this one. I bring some 1 coulomb of charge. Let's say there is one charge of 1 coulomb at a distance of 8 meters. Let's say it's here somewhere. Let's say I have a charge of 1 coulomb here. Okay. Now, if a charge of 1 coulomb is moved by me, I move that charge. I move that charge from here to a distance of 2 meters. Do you agree I have to do some work? Do you guys agree that I have to do some work? Amurudhar, can you throw that in the end? I'll read that otherwise. 1 second. Okay. Is it fine? Yeah, later. Yeah. Is it fine? I've brought it to 2 meters. Do you agree I've done some work in getting it from 8 meters to 2 meters? Do you guys agree with that? Yeah. Okay. I hope you agree with that. Yeah. And Mithul, the president, are you in the Oval Office? Okay, nice. Anyways, going ahead, listen to this carefully. Now, so the question is, work is done by me. Let's call that work VCA, getting it from C to A. Okay. Now the question is, how much is that work done? How much is that work done by me in getting it from, how much is it work done from getting it from infinity to that point? How much is the work done in getting it from 8 meters to 2 meters? Can anyone tell me how much is that value? Wrong. One of you is right. Who's that? Satvik is right. Okay, listen to this carefully. Understand this. Let's say this is infinity. Okay, let's call this infinity. This point infinity. Okay, this is infinity. Okay. Yeah, Ketan, you're right. Now tell me, how much is the work done by me in getting a charge from here to here up till 8 meters? How much is that work done? Tell me. How much is the work done in taking a charge from infinity to a distance of 8? You calculated in the beginning. How much was it? Yeah, Satvik, you're right. How much was it? Look at the problem. Electric field potential at a distance of 8 meters is how much? 18, right? So how much is the work done? Tell me. 18. Agree with that? Now tell me, how much is the work done in getting something from infinity to a distance of 2 meters? Tell me, how much is the work done? How much is the work done in getting something from infinity to a distance of 2 meters? How much is that value? You calculate in the beginning. 72, right? Agree with this part? Yeah. Now I have a question. If the energy required to go from here to here is 18 joules only, but from here to here, you require some energy, right? Totally require 72. So how much should be the work spent to go from here 8 meters to 2 meters? 54. Agree with that? Do you guys get this now? It's 54. If you spend 18 to get it till here, the remaining of the 72 should be spent here, right? Agree with that? If you spend 72 to come till here, if you spend 18 to come till here, to go from here to here, how much energy should you have to spend? From 8 to 2 meters? Just 54, right? 54 joules, right? Is that part fine? Does that make sense? Okay, now where is this? Okay, so the work done by me is how much? 54 gigajoules, okay? 54 gigavolts, or in this case, gigajoules, okay? Is this part fine? No, potential is not the same as work done. How 54? 1 second. Observe this. I spent 18 to come from infinity till this point of this radius of r. You got that part? Is that part clear, everyone? Okay. Now we know that if you were to come from infinity directly to 2 meters, you had to spend 72. So the question we ask is, if it takes 18 up till this point, let's say you come from infinity and reach this point, you're going to spend 18. And how much do you have to spend to go to from 8 to 2 then? If you just subtract, you should get it, right? Yeah. If you just subtract 70 to 18, you should get 54. Is that part fine? But if the charge we are moving is, yeah, then you have to multiply. This is for 1 coulomb. This is for 1 coulomb. Listen to this. This is only for 1 coulomb. I moved 1 coulomb of charge. That's why I'm getting in joules. If it is 2 coulombs, you will have to multiply. Is this part fine? Accordingly. Obviously, if it is 2 coulomb, don't you think the force will be greater? Repulsive force will be much more greater. In getting a charge from infinity, repulsive force will be much greater for a 2 coulomb charge. So far, we're discussing potential in case of only. Yeah, what I calculated just now is potential difference. Yes, what I just calculated is the potential difference. This is the potential here, and there was a potential here. I just subtracted them. What is the potential at 2 different points? I just took the difference between the potential. Listen to this here. I took the difference in the potential at 2 and 8. That's potential difference. Congratulations. Yeah. That's why they call me a battery, because I provided the energy and stored it somewhere. I'm the battery. Infinity to 8, I use the formula. Look, it says that it's 18. By definition, it says it's 18. That's how I figured it out. From infinity to 8 meters. Now, do you see something much more interesting? To get it from infinity to 8 meters, you don't have to spend a lot of energy, just 18 joules. But you have to spend 54 joules to take it from just 2 meters to 3 meters. Can you see that? Why is that? Why is that? Tell me. Yes, Shraddha. Yes, in that case, yes, you're right. If it's 2 coulombs. There's a stronger repulsion force closer, right? Yeah, force is stronger as you go closer and closer. Now, does that make sense? Does it all fit now? Why this formula looks like that? Why does it depend on 1 by r? Yeah. Now I want to add something. That's why we call it a battery. Okay, this is something very important at tell. Now let's say what happens is somebody lets go of this charge. So I put some effort. I put this charge from 8 meters, which was at 8 meters, and I brought it here, right? Now somebody lets go of this 2 coulomb charge. Oh, no. I'll come to that subject. Okay. So let's say I did that. Is this part fine? Let's say I did that. Now, when I let go, the repulsive force, do you agree that repulsive force will push the electron, push the charge away? Do you guys agree? Okay. Now I have a question. It will, let's say a charge moves to a distance of 4 meters. Then how much is the work done by the electrostatic force? Can you tell me? It's very easy. You just have to subtract the potential. How much is the work done by the force in taking from here to here? It's a difference in the potentials, right? Agree with that? It's how much? 36, right? Agree with this, everyone? It's not 18, it's 36. Because you are going from 2 to here, 36. So total is 36. Is this fine? 72 minus 36. It's 72 minus 36. Is this fine? In this case, it's going to be minus. Can anyone tell me why the work done is minus? Why would it be minus? Yes, it's negative. Because this time the field lost energy. Do you see that? Field lost energy. That's why it's negative. Earlier, I was storing energy. That's why it's positive. Every time I was getting charge from infinity, I was storing energy in the field. This time I release the energy. So it's minus 36. Is this part fine? Work done is negative by me. Work done by me is negative, but what about the work done by the electrostatic force? Is it negative? Is the work done by the electrostatic force negative? No, right? So the answer for this is plus 54. Do not mess this up. It's plus 36 itself. Is this part fine? Is this part fine? It's plus 36 itself. Because I have asked the work done by the electrostatic force. That's why I highlighted it. If it was like work done by me, then it would be negative. I understand. Is this part fine? Do you guys get that? Everyone? Whatever I'm trying to say is the work done by me in taking something from by one point to the next, from let's say 2 meters to about let's say 4 meters. Yeah, you might say it's minus 54. Yeah, I understand it's minus 54. That's the work done by me. But work done by the electrostatic force is positive. It did some work, right? It lost some energy. It did some work. That's why it lost energy. The field has lost energy. Do you see that? The electron has gone far. It was not. It's not close. There's no energy stored now. Some energy is lost because of the application of the force. Do you see it now? In the previous question. In the previous question also it is okay. In the previous question, work done by me was 54 positive because I took it from here towards that. Work done by me, I spent energy to take it from 8 meters to there. Yeah, it's negative because I just helped them out, or in some sense, I didn't do any work. That's one way of putting it. Work done by me is nothing actually, but work done by this thing would be positive. Is that part fine? We say work is, it's negative represents that the work is done by the field. See, there is a simpler definition, guys. I would go with this definition. We ask, okay, I think you will understand this definition better. Potential is defined as work done, or simply energy stored per coulomb in the field. Is this fine? This is the most simplest definition. Okay, now if you go by this definition, everything makes sense easily. Okay, because when that charge went from 2 meters to 4 meters, the field lost energy. So that's why it's minus. Is this fine? Potential difference is that. Yeah, kind of. Isn't the field in the opposite direction? Yeah, that's why the field did not do any work. I did the work. Field is in the opposite direction. Field did not do any work in the previous question. In the previous question, it will be negative. Yes, in the previous question, field did negative work. I did some positive work. Okay, I did some work. Particle went in the direction of my force. It didn't listen to the field. Field didn't do any work. Will you change the kinetic energy question? Will you give the charge kinetic energy when you move it from infinity to some point R? No, we do it slowly. We do it such that it doesn't go there. Yes, that was Anika. It was, yeah, 72 minus 54. That gives you that. Now that's 36. I hope that's fine. Okay. Where, how 74 minus 36? 1 second. Yeah, listen to this. The work done by the field is nothing but the change in potential difference across it. Okay. We are trying to calculate how much is the potential difference. That is V. So it's 72 minus 36 to go from here to here. The potential here to here. Is this fine? Is this fine, guys? Now? No. Okay. 1 second. See, if you are going from, the idea is something like this, simple. If you were to move from here to here, if you were to move something from here to here, you will be releasing some energy of the field. You'll be giving some energy to that 1 coulomb charge. Okay, it will go from 2 meters to 4 meters because of the repulsive force. So in that case, the potential, the energy, the amount of energy released is simply going to be the difference in the potential at those points. It will be simply potential difference across it. Okay. Now, why it will be just potential difference across it? Because what is potential difference? Work done per coulomb, right? Work done per coulomb. But in our case, coulomb is one. It's 1 coulomb. So it's simply going to be the potential difference. Is this fine? So that's why we end up subtracting. We want to find the energy, how much is the work done. Work done is nothing but V into Q. But Q is 1. Okay, if that's clear, they call me the battery. Okay, now I have a question. I noticed that the charge gained some kinetic energy. How much that kinetic energy will be? When I did this, when this happened, when the electrostatic force took that thing from 2 meters to 4 meters, I noticed that the charge gain, where 1 coulomb charge gained some kinetic energy. Is that fine? How much is that kinetic energy? Tell me. It's very easy. It's the same thing, right? How much electric field lost should be gained by the electron. Agree with that? Kinetic energy gained by the charge. Do you guys agree with this? So it'll be 36. Is that part fine? The question is this. I noticed that the charge gained some kinetic energy. How much is that kinetic energy? That's all. It's energy work theorem. Yeah, energy work energy theorem. It should go there. Yeah, there is one more there. I'll come to that. Yeah. Is this part fine? Yeah, it's not lost. It's transferred to the particle. Now you can use this. You can use this. Sumit, that's because of last year we had the work energy theorem, which says that energy gets whenever you do work, whenever you convert potential. Okay, in simplest sense, the energy has to be converted to kinetic energy from the stored energy. That is potential energy here. Field is losing energy. Field is losing energy. I understand. Field is losing energy. Yes. Okay, why is the field losing energy? Because the field did some work, right? Agree with that? Field is losing energy because field did some work. Agree with that? Yes. Now I have a question. The electron went in the direction of the field. Agree with that? Direction of the force of the electrostatic field force. Agree with that? The electron gained energy. So the field did some work on the electron. So that's why F into S is positive. Work done by the field is positive. Work done by the field is positive. Is that part fine? Work done by the field is still positive. It did some work. It gave some positive energy to the electron. But the field had to lose some energy. And that loss of energy is 36. That's what we were calculating here. See, work done by the electrostatic force is 36, is positive. It gave some energy to the 1 coulomb charge. But the field lost some energy. That is what is captured by this formula. V is equal to K times Q by R minus the when you subtract the potentials. So electrostatic force is transferring energy to the particle, which it uses to change its configuration. It doesn't just the energy is transferred to the particle. Wait, I'll tell you what happens next. So I stop this charge. Listen to this. I stop this charge via some mechanism. Let's say I did some mechanism. I stopped it at 4 meters. I took all its kinetic energy. I made its kinetic energy 0. So which means I took some of the kinetic energy with me. I took all of that and transferred it to a device which produced light. Okay, I took all of that energy, kinetic energy of the electron, and transferred it to a device by making it, let's say, that kinetic energy, somehow I converted it to produce light. I then let go of the charge. So the charge is now sitting at 4 meter distance without any energy. Is that part fine? Without any kinetic energy, at least not kinetic energy. Is that part fine? Now the charge is again moved by the electrostatic force to a distance of 8 meters from there. How much is the work done? Everyone tell me. It's very easy. How much is the work done? It's a difference in the potential between 4 meters and 8 meters. How much is that? Just 18, right? It's very less. It's obviously less because you know this should be less. This is common sense. It should be less. Yeah, because it's very, very far. Now, I noticed again this thing gained some kinetic energy. Can you tell me why? How much is the kinetic energy that was gained? 18 joules itself. Is this fine? Okay. Now, here's an important observation. I started with 8 meters. I started at 8 meters. We're back there. But if you look at something interesting, in the beginning, I had moved 1 coulomb by distance from 8 meters to 2 meters. How much energy did I spend? If the charge is 0, no work is done. If the charge is 0, Satvik, no work is done. 0. You don't even have to spend energy to move the charge. A neutral. To move a neutron around in an atom, you don't have to spend any energy. Okay, I had spent 54. Agree with that? I had started with 54. I had started with 54. Now, do you see something interesting has happened? I have used some of it energy, some of that energy, 36 joules of it, 36 gigajoules has been sent to produce light. And 18 of it is now in the electron. Agree with this? Do you see the idea of potential gains and drops here now? We gain potential and then we lost potential by going from 1 meter back to the 8-meter gap. Do you see the connections? So that's why I've said, look, I've added a line there. It's not like I always change, I always, take something from 8 meters. Sometimes on Earth, I lift 1 kg masses from a height of 0 meters to 8 meters too. He's like, you see how easy it is. You know what happens when you take some object to a height of 8 meters and let it go, right? It releases a lot of energy. But there you wouldn't call me a battery, you will call me a dam. What is a dam at the end of the day? It's basically something that stores energy, right? That has stored a lot of energy. A dam is nothing but a reservoir of energy. It's a battery. Dam is nothing but a battery at the end of the day. It's storing energy and letting go of water. It has stored energy, yes. We call it potential energy. It's basically a battery. It's the biggest battery we know of, actually. A dam is a very big battery, comparatively. One of the biggest batteries. Okay? But when you think about it, dam is actually not doing any, it's not doing any work. Dam is just storing it. The work was done initially when you think of a battery also, did battery do any work actually? The work was done initially, right? When the electrolyte separation occurred, when the electrolytes were separated in a solution, that's where the work was done, right? We had to spend some energy to provide that electrolyte solution for the battery. Yeah. Work is not, no, I'm saying sun actually does the work. I'm saying sun actually stores the energy. Sun actually takes the water to the clouds, right? It takes the water, lot of water to the, in fact, rivers and rivers worth of water to the sky. Okay, and then lets it go every year as rain. Sun does that. Okay, so at the end of the day, it's basically that same process. Nuclear plant also can be really rare. Nuclear plant is nothing but a heat engine at the end of the day. It's simply a heat engine. Nuclear, this thing is simply a heat engine at the end of the day. Okay, last part. And then I'm going to be done. Don't worry. This is the last part I'll discuss. Listen to this carefully. Again, I have a 16 coulomb charge. I move an object along certain paths. Sun is applying no force. I understand. You see that sun is not applying any force. How 18? 1 second. Which one? G. G is 18 because the thing went from 4 meters to 8 meters. At 8 meters, it was 72. At 4 meters, it was, I think, 54, right? How much is it? 36. It was 36. At 8 meters, it was 36. So the difference in that is 18. Is that fine? In G, I say one charges. Zero kinetic energy. No zero charge. The kinetic energy is zero, not the charge. Charge is positive, still that 1 coulomb itself. Kinetic energy has become zero now. Okay. Yeah, sun is applying a force against gravity to get, yeah, that's how it is put. Yeah, Muralidhar, yeah, Nidhi is right. Yeah, Nidhi is saying sun evaporates, right? When you evaporate, what's that mechanism actually? You have to heat the water, right, first to make sure the molecules rise, come out of the water. So sun is spending some energy. Okay. Yeah. What's wrong with you, Vivek? Seriously. Yeah. These things are very important. Anyways, now these details are very important. Yeah. Now going ahead, here we have one more situation. Okay. Yeah, he's in a hurry, very case. Okay, nice. So listen to this. We have one more idea that there's a charge Q, let's say, at 16 coulombs in the center. I take something along the path A, B, C, D. How much is the work done? Total work done. Now, why we say total work done? Because, listen, we'll have to take it from here. Somebody, I might do work, but in the other context, somebody else might do work. Force might do some work. That'll be negative work. Okay, how much is the work done? If I take something from A to B, how much is the work done? You guys know this. How much is the work done from taking it to A to B? First A to B. How much is that? 36. How much is the work done from taking to C to D? 18, right? So the total work done is how much? 54. Agree with this? But I have a question to you guys. Did it even matter? Why 36? Because that's the difference there. The difference from this level to this level is 36. Okay. Yeah, that's the very Murali that made that point. Do you see something interesting? It didn't even matter. B and C didn't matter. B and C did not matter. A and D only matter. You just have to take the final potential and subtract from the initial. That's all you have to do. You could have just done 72 minus 18 and you'd have gotten the answer. Is that fine? Yeah. Now observe one more thing. How much is the work done in taking something from B to C? How much is the work done in taking something from B to C? Okay. Do you know something called a wire? How much is the work done in taking charge through a wire? 0. These are wires here. These are nothing but wires. They are the same potential. This is nothing but your wire at the end of the day. This here is your battery. This is your resistor. Is that part fine? So that's what you've been doing all along. It's basically that. You have been, Vivek is in a hurry, very much. He's going crazy. Okay, yeah. So now listen to this. So what is the work done in moving from D to E? Tell me. No, battery is not getting charges from infinity to a wire. Battery is basically taking it from the ground. Infinity means the ground, yeah, zero potential. It's taking from 0 potential to some high potential of 5 volts or 6 volts. That's what it's doing. Storing it at some voltage, like 30 volts or something like that, from 0. And then we are letting it go inside a resistor. Resistor is a device which converts something to light. Yeah, D is 0, D is 0. ABCD was how much? I think 54. Now here's the thing. What about this one? How much is the work done here? Answer me this. How much is the work done? Murali, you're right. 1 second. Satvik, you're right. How much is the work done in this case? A, B, C, D, full path. It is 0, right? Because you do some work that'll be cancelled by the this thing. What is that? The electrostatic force. Now listen to this part very carefully. Listen to this. This is Kirchhoff's rule. This here is your loop. You're going around in a loop. Amount of drops is equal to amount of gains. These are your drops. These are your gains. This is where you gained something, but this is where you lost it, lost the energy. Is this part fine? Vivek, you can't leave. Yeah, you'll be marked absent. Now, is this part fine? Yeah. So my point is, throughout this topic, what you were doing, this is basically a circuit right here before your eyes. Okay, what about FGAB? Look, FGAB, if you go, okay, what is FGAB? How much is it for FGAB? Tell me. When you go from F to G, how much do you gain? How much do you gain? How much does the field gain? Tell me in general. 36. But does it lose here? 36. It might give it to some resistor here by some mechanism. So does it summarize everything for you? Yeah. Other things you'll have to solve. Okay. This problem number 5 you'll have to solve. Problem number 6 is easy. You can solve. Problem number 7. You'll receive an email with the forms. Others you can solve. Now there is one more. Now listen to this. This is fine. All of this is fine. Why are you asking us to find out work done, but why are we finding potential? You're calculating potential difference. So I'll tell you what's happening there. You're calculating the potential difference. You're calculating potential and the potential difference. Once you calculate potential difference, you're multiplying it by 1 coulomb to get the energy. Because voltage is nothing but, potential difference is nothing but, yeah, work done is equal to potential difference into this thing. What is that? Charge. That's why. Work done is not equal to potential difference. Work done is voltage into this thing. Yeah. Vivek, you're going to be wasting that time playing games anyways. So why? Yeah. Okay. Anyways. So here we go. Listen to this. Okay. So with that being done, there's one more part of it which I need to discuss. Yeah. Some of you confused whether it's 16 coulombs or 1 coulomb. Listen. We did not get 16 coulombs from infinity. 16 coulomb was there. It was fixed. We got that 1 coulomb from infinity. We spent energy on that 1 coulomb to bring it there. Okay, that's why we're multiplying by 1 coulomb. If you get 2 coulombs, you have to multiply by 2 coulomb. We have to get it against the field of the 16 coulomb, this thing. Yeah, kind of, yeah. Nah, no way, Medan. It does. I agree with that. But that's not a problem. But we're going to be right now. It's not needed. We have to finish this. So, if both charges were not fixed, would the field have spent twice the amount? See, if you let them go, you will be still releasing the same amount of energy. But the problem is the moment you do not fix them, they start moving. It leads to some problems because when they start moving, they generate magnetic fields, and that leads to complications. So we just in electrostatic, we try to avoid that as much as possible. But the idea is if you let them go, yes, you're right, it will be released that way. Yes. Next question. Would this be asked in the exam? Yes, I'll be definitely asking this in the exams. Okay, definitely asking this for sure. Okay, this is like the basics of this thing. 1 second. I think my chat box is stuck. 1 second. This is delaying the class. Thanks to Anish. 1 second. Yeah, this will be asked the exam. Will it be specified to all value? Yes, it will be specified, but we are doing it for one. Could we discuss? Yeah, we are doing workbook problems as well as that live chapter next class. Okay, that's what's happening. But I'll discuss this for the exam sake of point of view. It does not matter in the end if the charge is 1 or 16. It matters because the amount of work done depends on the charge. Yes, I'll be discussed. Will there be any derivations? Yeah, Wheatstone's bridge. By the way, I have to tell you something. Skip all this. This is all there. You have to solve bunch of resistance problems. I wanted to do all alphabets from A, B, C, D, E, F, G, but then I stopped at W because your classes started then. Okay, there are about so many equivalent resistance problems. They're very easy. U, V, W. It stops at W. Okay, so I wanted to finish the English alphabet completely. Okay. Anyways, I'll do the EFG. 1 second. I did it actually. Your messages, I didn't receive them, half of them, thanks to one person probably. Now, is 1 coulomb the default value? No. We are saying work done. See, potential is defined as work done in getting 1 coulomb of charge. That's the definition. Is that fine? Yeah. Next part. This is a fun one. Please try solving this. Okay. You have 4 resistors. This is actual practical stuff. You have 4 resistors, but you want to produce 0.6 this thing resistance 0.6. You have just these many available in your hand. You have to produce so much charge. How would you do that? That's the question. It's a puzzle based question. This is level 1. This is puzzle. This is just a puzzle. You've been given some resistors. You have to use them to produce a combination. Yeah, DPP, your answers will be in integers. All your answers will be in integers. DPP answers. Yes, Keithan, I'll come to that soon. Next part, last bit. This is something I want you guys to crack. This is an easy problem. This appeared in British Olympiad. Okay, and it was listen to this. This is a British Olympiad problem, but it's very, very easy. It looks very hard. I want to see how many of you can crack this. What it says is determine the value of the resistance required so that you minimize the heat generated by 5 ohm resistor. This 5 ohm resistor. You want to minimize the heat generated. Now, how can you minimize the heat generated? Do you agree heat depends on power? Do you agree heat depends on power? Last part. Yeah, power is nothing but I square R. Now, if you can reduce the current completely, do you agree you can minimize the heat? Do you agree with that? Okay, so we got to make sure the current in this branch becomes 0. Is this part fine? We got to make sure that 5 ohm current through the 5 ohm resistor becomes 0. Is this part fine? We have to adjust R so that current through that 5 ohm resistor becomes 0. Is this part fine? Is this a Wheatstone's bridge problem now? Almost. Observe this. There's one more detail you got to see. Do you see this part? This is a single resistor actually. Even this is a single resistor here. These both are single resistors. If you combine them, immediately it becomes a Wheatstone's bridge. Solve the problem, you're done. Wheatstone's bridge condition is simple. This resistor P times Q should be equal to R, this together, times S, that is 4 ohms. Q is this thing, 12. So to make sure the current through 5 ohm is 0. This is a Wheatstone's bridge problem. Just try this out, okay? Is this part fine, guys? Are 10 ohm and S ohm are in parallel? Yeah, they're both in parallel. I can solve it for you directly. It's very easy. The problem is very easy. Do you guys want to do it or should I solve it? It's very easy, that's right. This together becomes how much? Yeah, you'll do, right? Yeah, okay, fine. This is doable. Next part is level 2. Here you go. Your present is here. big circuit. I'll give one question like this, don't worry. Okay. This is a fun one. This is an easy one. This looks complicated, but this answer to this question is one line. Answer to this question is one line. You get the answer. Okay. I want to see who will figure this part out. Okay. It's just one line answer for this question. Others you can try solving. The International Olympiad problems, IPH and all, 1996 and all, I put them. Others also. You can try them on your own. But leaving that aside, it's just one line answer for this. Now, somebody told me to go back. Is there a time limit for the questions? For the exam, yes. On an exam, there won't be a time limit for each question, but there'll be a time limit for the whole exam. Okay, that's it. Just like normal. Did somebody send anything? How much is compulsory? Level 1 is compulsory. Level 2 is not compulsory. Okay. Level 1 is compulsory. So till here, you're supposed to answer. Till problem number 13. Is this fine? I'm sorry, you'll have to answer that. Okay. I know today was tiring. There's a lot. Okay. One second, Shashank. We'll cheer them up. We put some music in the other batch. I'll put them for you guys also. I don't know if it works. We played this. We wanted to say goodbye to all the numbers earlier. So out of respect, we played this for them. Okay, earlier. This one. Because they had to let them go. I know volume is very high, I get it, but they had to let go of the numbers and all that stuff. It is frozen, obviously. We were playing frozen. And I thought it'll be fair if I play it for you guys. Where to submit the workbook answers? There'll be a form on Google for submission of that. Okay, don't worry about that. Okay. Muralidhar, yes, Muralidhar got the answer for the Wheatstone bridge problem. It is easy. It's very, very easy. Yeah. EFG, I'll play that. Coffin song next time. Let's see. For now, bye-bye, guys. Take care. And yeah, I know you're tired. It's Saturday anyways. Enjoy. Stay safe. Take care. Yeah. Bye-bye. Take care. See ya. I'll copyright you. Why? What did I do? Okay, so that's about it. You'll receive the link. Please answer. Your exam has been postponed one day. Ashi asks, are imagined numbers real? Yes, you can put it that way, kind of. Imagined numbers are real. They are not any special. They actually are real. You guys can leave. Yeah. If you have any questions, I think somebody asked me to do EFG, right? One second. EFG. Let's go back to EFG. Where is EFG? Yeah, you'll receive an email, so don't worry. The cat problem. Okay, one more thing. I got to just speak about the cat problem. Amit, you're right. Once again, I want to discuss about the cat problem for a reason. See that. How many of you got an idea? Very close. How many of you are very close to the solution or have a lead with the cat problem? I want to just give you some guidelines, because even last year I gave guidelines on how to go about it. It's a beautiful problem for a reason, actually. Yeah, see the cat problem, you got to stop looking at it as a complicated problem where there are 3 cats moving. Instead of that, you start asking, what will one cat start see? What will one cat see? You ask yourself, what does this cat see? That's all. Then you start realizing, oh, the problem is very simple. If you look at it from one cat's perspective. Yeah, the concept lies in relative velocity, yes. You just have to ask yourself, what happens if one car is going towards each other? Let's say one car is going at 50 meters per second. The other car is going at 20 meters per second towards each other. You know the velocities get added up, right? So you just require those ideas. What does it look like if you sit in this car? It looks like the other car is coming at 80 meters per second or 70 meters per second. So that's the idea. That's the clue to solve that problem. You got to understand what's happening. You don't have to look, you have to see the problem from the perspective of a single cat instead of looking at it from outside like that. The solution will blow your mind. It can be done. I usually do it in volume 1. This time I thought I'll keep it here. Yeah, there are formulas for that, yes. Okay, going back to something that was asked of me, 1 second. Yeah, for EFG, where is EFG? Path EFG. Yeah, for EFG path, if you look at it, you go from here, E, to G. So the work done here is positive. It's going to be how much? You're storing energy in the field. So it's going to be 56. It's not 56. It will be 54. ABCD is minus 54 specifically. Okay, the work done is minus 54. Is that fine? I'm not sure this thing. One second. Can you guys see this thing? I think you can see the answer, right? EFG. I receive the messages now. Yeah, Amit, you're right about that. That's the answer. Whatever is saying. Okay. I'm showing you the answer question, right? Can't you guys see the screen? Can't you guys see the OneNote? Keith and what? What is the what 13? I didn't get that. Yeah, I'll check your answer soon. I typed it 5 times. Okay, now send it, Shashank. I think I'll be able to read it. I'm skipping it because others are sending so many messages. You can't see it. EFG is minus 54. Yeah. No, EFG is 54. ESG is 54. Wait, I've shared the one print this thing. OneNote. It's here. 54. This is 54. This is minus 54. The earlier one. How is that true? There are many grounds. I don't know. What is that? Q is not seen. I can see the question. Yeah. When will you take Viva? I have no idea. 1 second. I might have missed Shashank's question. Yeah. EFG cancels ABCD. ABCD basically ends up. I'll do that soon. Probably some time after another class. Okay, it goes from 2 meters from vertex, but B moves 2 meters to vertex C. C can go to previous vertex. By the way, one more thing, the cats do not move on that line. Cats do not move on the triangle. Cats never move on the triangle. No, Shashank, you messed up something there. Shashank, I meant. They don't go on the line. They go like this. This is what their movement will look like, all the 3 cats. They'll end up forming a spiral like this. They will not go on the line because one is trying to follow the other. The hint is this. Second hint that you need to solve that problem is this. The fact that that's the first hint, that you need to have that relative velocity concept. That's important. And then there are some other concepts which will be of much more importance. That is not your question. Oh, your question is about not the cats. It's about 2 meters. Okay. So A goes to 2 meters to B. Okay. B, from B you go to C, let's say 2 meters. C can go previous position of A. Let 2 meter, okay, and maintain symmetry of the current position, that is of LA. Okay, I think Shashank, you'll have to say that question. You typed out, I did not get that. Okay, I didn't get that. Now listen to this. I didn't add one more detail. In this diagram, it's not just this path. You can go any way you want. You can do whatever you want. But if you come to this same point, the work done is 0. Shashank, you'll have to talk. I'm not able to what you say. Understand the question. That's why. I understood you're going from A to B, B to C, and all this stuff, but I didn't get that. Yes, Satvika, that's right. FGAB, okay. Yeah, FGAB, if you're going from here, FG, you're gaining here, I think 36, but you lose 36 here at AB. So it's 36 plus 0 minus 36, effectively giving you a 0. No, Shashank, that's not the case. Yeah, conservative passes on a closed path. Yeah, that's basically an integral actually. Yeah, only the integer part. Yes, I'll be specifying that in the DPP problem set, which you'll receive. Don't worry about that. Okay, if 2 positive, one second. Oh God, one second. I missed Shashank's thing. One second, Shashank.
A has moved some distance on the triangle. Where does C move towards position A? On the triangle, which are we talking about, the cat problem, Shashank, or this thing, the regular this thing? Okay, if now we have two positive charges together, Murali says, and we leave them, they accelerate in opposite directions in equal amount. Then we can measure the position of one and the other's velocity. Yeah, that's the EPR paradox, Murali. That's the EPR paradox. That's what Einstein did to break quantum mechanics. He exactly fired that bullet there only. But what happened was, Einstein was like, when you do it, you're not breaking the unsaid principle. What happens was like, see, one is doing a measurement somewhere really far. The other person is doing a measurement kilometers across. Okay, so this guy knows about the velocity, the other person knows about the position, but can they talk to each other instantly? No, right? So effectively, you have not done anything better. You're still under the mercy of unsaid principle. And 13 questions are 10 ohm and 12 ohm parallel in 13 question. 1 second. In the 13 question are 12 ohm and 10 ohm parallel. No, 12 ohm and 10 ohm are not parallel. You can see that they're not parallel. Parallel doesn't mean they should be in lines like this. That doesn't matter. If you look at it here, there's a problem. The one end of the 10 ohm is connected to 12, so you can say that's fine. But the other end is not connected to 10 ohm. The other end is connected to 5 ohm. If it was connected here, I would say it was parallel. If I remove this 5 ohm, I directly say this, yeah, it is true. They're parallel. Yeah, so I know there are too many questions, but due date is fine. It's Tuesday. It's just Tuesday. Yeah, please, Shashank, mail it to you. At the problem, okay. Why would call cats follow each other? I have no idea. But the most satisfying can be that the very act of measuring affects another. Yeah, that was the question. Does it actually affect the other? Einstein was like, it doesn't. Bohr was like, it immediately does. Yeah. So in the workbook, there is a problem to find current, but EMF isn't given. Yeah, I know about that. That is the issue. The EMF is 12 there. If you don't know the question, the EMF is 12. I know the question. What you're talking about. Just take EMF as 12 and solve the problem. You'll get the answer. There was a mistake there. Muradhar, I read a sci-fi book as to how we can teleport ourselves. Okay. If we somehow reduce the rate at which electrons, electron would revolve, we can reduce its energy. As energy is inversely proportional to degree of weather, we can have more wave-like properties with speeds. We can also create multiple images of ourselves. The part where the hero creates multiple images of himself to confuse the villain. Okay, since a huge velocity by uncertain, our positions will be uncertain. Okay, that is possible. I don't have a problem. But you're dealing with macro objects. Your wavelength is very, very short. Very, very, very short, your wavelength. As particles become, what do you say, very, very large, their wavelengths become very, 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 what do you say, you become more like particle. You are no longer wave. You become more like a particle. In fact, your wave becomes your wave function. This is what your wave function looks like. You're a peak exactly at some point. You're a wave with a peak, showing that you're there. Wave function becomes that. It's no longer a wave which goes from one end of the universe to the other, where we are not sure where you are. Okay, Satvika sent something, but apparently, okay, she said okay. Which question? I have no idea. When will we result the optics? By Monday, hopefully. I'll be finishing by Monday. You'll get it. When should we submit the workbook? Soon, once I finish the workbook. Which is on Monday, okay? I'll finish it on Monday. Yeah, sure, Muradhar. I'll look into that. Could you do the Wheatstone's bridge derivation now? Oh God, that derivation took me
half of a class. Okay. Anyways, I can, not a problem. I'll just do it very quickly though. Okay. Can you please explain question number 13? No, nothing. 13 simply says there's a 5 ohm resistor. You want to make sure the heat released by it is very less, as minimum as possible. The minimum that we can do is 0, get it to 0. Okay, minimum we can do is get it to 0. The question is, if you want to get it to 0, the current through this 5 ohm resistor should be 0, current through it. So then it's a Wheatstone bridge condition. We want to make the current through it 0 by adjusting R. So that's why it becomes a Wheatstone bridge problem, which you'll have to figure out how to apply Wheatstone bridge or something like that. Next, sir, why can't battery just extract charges from the universe? I mean, from objects around us and place it in the wire. Okay, the problem is that's possible. I'm not denying that it's not possible. In fact, what is do you know about that machine where the Mr. Bean holds his hand on and the hair stands up? You guys know otherwise also, right? That machine where you put your hand on it and the hair starts standing up. Yeah, what do you think is underneath that? It's called, I think it's called, I've forgotten, Van de Graaff. Underneath is a belt actually. Underneath is just a simple belt, okay? Which has some brushes which scrapes electrons from a metal and takes them up and puts them on the other metal. The brushes move so fast, they pick up the electrons from the lower piece, that is this, what to say, metal. There's some help from electrical sources also. Yes, you can leave. And puts them on the sphere. And that's where it stores the charges there. So it's basically doing some work in taking something from the metals, other materials, and putting it on the sphere against this thing. You must understand it's doing a lot of work because already there is like 30 coulombs here. You're getting charges and putting it again on the dome. So you're doing work. Okay. And again, as the charges grow, this becomes 60 coulombs. You have to struggle even more. The brushes have to struggle even more to take something from the metal and put it there onto the sphere. So yeah, batteries do that, but chemical batteries are the best because in chemical batteries, in chemical solutions, we already have electrons, rich electrons. We have these solutions called electrolytes, right? Which have a lot of electrons, which are that's why called electrolytes, right? Because they have very rich, what do you say? What's that term called in chemistry? I'm not getting it. But anyways, I think you got the point. Yeah, is the belt doing work? Yeah, kinda. Belt is doing work, but that motor, you try to turn the belt, you require motor, right? That requires energy. So you're giving energy to the belt by turning the motor. Yeah, 1 second. I'm getting some questions, so I was just taking that. Can you go to the maze problem? 1 second. Yeah, resistor maze. This is a fun one. Just look into it. I'll post the DPP soon. Okay. Now, done. I have to do the Wheatstone bridge thing. Okay, I'll do it here only. It's easy. There is white space, so I waste it. Here. Okay. Well, okay. Can't do it very well. Done. Stop. Now, so Wheatstone bridge works like this. We have a battery. Okay, I'm not going to do that. Let's say this is ground at 0, and this is at a voltage of V, a voltage of plus V. Okay. Now, let's say there are 4 resistors coming out of a branch. 1, 2, 3, and 4. This is resistor P, this is Q, and R, and S. Now, there is one more resistor in between. Now, the thing is, I don't want any current to flow through this path. I don't want any current to flow through this resistor. Now, if that has to happen, I know that the voltage across both ends should be the same. I'm going to call that voltage V1. Okay, both the voltages, the potential at those points should be the same. So this is at ground potential 0, this point. But this point should be at voltage 1. This also should be at voltage V1. Then the potential difference across them, V1 minus V1 is 0. So no current flows through this resistor. That's what I have to achieve. Now if I have to achieve that, let's say we achieve that condition. Let's say we achieve that condition. We ask ourselves, what should be the relationship between PQ and R and S? Okay. Now, if no current flows through the resistor, do you agree I can simply throw away this and the circuit is simply a parallel circuit involving PR, QS in series? Okay. With that being said, I want to maintain the same potential at this point. Here also it should be V1. But what is the potential difference across the resistor R? It's nothing but current flowing through it, that is I1. Let's say I call there are 2 currents, I1 flowing through this branch and I2. It's simply going to be I1 times R. V1 will be nothing but I1 times R.
But the potential difference across S, that is 0 to how much potential difference we achieve, that is nothing but V1 minus 0, which is V1, will also be nothing but V1 is equal to I2, the current in that branch, times S. I hope this much is clear. Now, if I want both to be equal, V1 here also, this end also it should be equal, the other end also should be the same, then do you agree that I1 R should be equal to I2S? But we have figured out that I1 is nothing but, in this circuit, I1 is nothing but, wait, I1, what is I1? One second. Yeah, I1 is nothing but V by P plus R, the total resistance in this branch. Similarly, I2 is nothing but V by Q plus P plus R here. Is this part fine? In the maze, does the current flow through the middle resistor? Is the answer to this 0 because there are two batteries? Okay, think now. Okay, I'm that. Good. It's not 0. In the maze, does the current actually flow through the middle resistor? Maybe, maybe not. I don't know. I'm not going to help you with this. This is a fun problem. It's a one-line answer. I told you, right? I know the answer directly when I look at it. I'll write it in one line. There's the answer. This is called a maze for a reason. It's called a maze. You'll be shocked how simple this is, the solution to this. It looks complicated and ugly. The answer to that is very simple. Okay, is the answer to this? No, it's not. Now, so because of that, if you do the substitution as I1 as V by P plus R into R, and this is equal to V times Q plus S into S, then VV gets cancelled. You get the condition PQ is equal to RS. Yeah. Is the answer 0 because of the batteries? Okay, DJ. What? DJ. Aage DJ. I think it's Hindi. Ajnya. I'm not even understanding. He's speaking. You're typing Hindi. Okay, fine. Adios, adios, Saujanya. Adios. See you tomorrow. Yeah, I'm bad at Hindi. Ajnya. There's a J, dude. Just Agya Dijiye. Just Agya Dijiye. I'm like, what is that? Okay. Yeah. Okay. So Wheatstone's bridge is done. Okay, fine. Solve this also. This is a fun one. This is about voltmeter connections. And it's a fun one. Like, this will blow your mind. This problem is hard. It's really hard. This one. Others are okay. So try this out. Okay. Anyways, bye-bye, guys. Is there anything? Yep, bye-bye. Yeah, 90, yeah, right. Yeah, right, 90. Awesome. That's an easy one, actually. It's not really that hard. But it came in British Olympiad. I don't know why. Are those kids that dumb? Oh, no, they are not, actually. This is for 10th standard. If somebody gives this without teaching Wheatstone's bridge, they'll die. Okay, without Wheatstone's bridge, you'll die if you don't know Wheatstone's bridge. That's why I said you need Wheatstone's bridge everywhere. In most problems, they test that. Nowhere is a grounding in the grounding. What grounding? Problem with maze. You don't require ground for this. For this maze problem, you don't require. Is a current 1 for the maze problem? No, it's not. It's not that simple, but it's a maze for a reason. You'll know. I'll solve this after the exam because I'm asking this question in the exam. That's right. At least similar to this. That's why I'm not giving the answer. Figure it out. Okay. It's in some of the books. The problem exists in one of the books. It's popular. It's very, very famous. It's on the internet also. Okay. Anyways, that's all I can give you information. Okay, I'm giving it for the exam for sure. Last year also, when I gave 2 years ago, when I did this thing, I told them this question is coming. Do what you want. Solve it. 2 people solved it finally. Figure it out. Kind of. Which book will I help you with that? Figure it out. There's one workbook question which is wrong. Yes, I know. There is a 12-volt supply. You need to use a 12-volt supply. EMF is 12 volts there, which is erased. Nah, solve it. Due date won't be extended. Okay, you'll have enough time. Don't worry. It's easy. The problem set is easy. It's not really that hard. Workbook, no, not the workbook. Just finish the DPP. DPP workbook you can worry about later. Okay, yeah. Bye-bye then. See you guys. Which question is 12 volt there?
there is a question you'll realize you can't solve that without using that. Okay, I think I'll work. 1 second. It's here only somewhere. That's I'll open. It's easy. 1 second. It's stuck for some reason. Yeah, if this is your
4A, sir.
it's 4A.
It's 3. It's 3. It's 3.
3. Okay. It's 3, it seems. 3A or something like that.
No, 3 has only one question.
Okay, 1 second. I'll search. Textbook here. Got it. Work. I think you're talking about exactly this question. Wait. This one? Yeah, this one. 3. Yeah, you're right. 3. In series and parallel, the third question cannot be answered. The fact that nobody asked that means that nobody worked out this section of the workbook. Almost. Okay. Anyways, there's a 12 volt. I think many people skipped it. Okay. Yeah. There's an issue there. Morelder is back now. He's in the waiting room. Let's just, okay, I'm not going to end the meeting just for that reason. Let's see what he has to say. Murali Baba, where are you? I bet I'm imagining his face eating something right now when the camera turns on. Irrespective of whether it turns on the camera or not, I have that image in my head right now. Yeah, expected. There is something in his mouth. Expected that. Okay. Anyways, yeah, why did you come? We're done with the class almost. Don't type, dude. Turn on the microphone. There is a provision. No. He has an answer. Wait, let me check. He has an answer. How did you do it? Just write me the line. How did you do it? Wait. Mia's problem. One second. I will have to search it. 1 second. I'll have to get the question. I have to see it and answer. 1 second. I'll look at it and tell 1 second. 1 plus 4 volts, right? 4 minus 4. 4 minus 4 minus 4. 1 second. Minus 8. No, you're wrong. No, it's not. I don't think so. Yeah, no, it's not. I'm thinking, wait. I don't want to be wrong about this, but I don't want to show you the screen also when I solve it. Okay. Hope I'm not wrong. Minus 8, minus 12. 1 second. No, it's not. You're wrong. No, it's not. Sorry, it's not 1 ampere. Is the maze so that the current will navigate through the rest irrespective of what? No, that's not simple. I'll tell you, I'll give a hint. Kirchhoff's voltage rule is the answer. Kirchhoff's voltage rule is the answer for this. One line answer, you're done. Wait a second, okay. Stare at that diagram. There is Kirchhoff's voltage rule there. This will give you the answer directly. I'll give you one more hint. Do you want one more hint? Or just the hint is sufficient? Okay, no. Okay. One more hint will kill it. Done. It's done. One line answer. If I give the second hint. What? Extra string. Advantages. I didn't get that. Okay. Give a hint. No. Wait. Let's see. The problem is if you guys are still cracking. Nope. Sumedh, I don't. No, it's not 1 by 4. The solution will, what do you say, astonish you. It's like so simple. No, it's not 19. It's not 7 by 18. No, it's not. No, it's not 1 ampere. That's the first question. First thing Murali told me. No. Wait, let me check. If both of you got the same answer, I'm worried now. I could be wrong. 1 second. I'm secretly doing some calculations on a separate screen just to be sure. Like, I saw it, but then all are 4 ohm and 4 volts. Okay. 1 second. Done. I'll solve this 1 second. This is Murali versus Prajwal. Let's do the calculation quickly. No, it's Murali versus Pajju. Okay, we'll go with that. Now, 1 second. No. Everybody's like 1 ampere. Now I'm worried. Everybody's like 1 ampere. Now I'm worried. 1 second. I could be wrong. We'll go with yes. Here. Okay. And here it will be 8, 12. Go like this, like this. One second. I got the answer. Yeah. 1 ampere is not right. 1 ampere is not correct. Yes, I feel good. 1 by 4 is not right. 1 by 5 is not right. Sorry. Okay, I'll give one more hint. No. Okay, fine. It felt like there's mental patients stuck in glass houses. They can't speak and they yell, right? No, not 5, not 1 by 6. Look, Kirchhoff's law.
Wait, sir, almost.
Okay. Now I know how to kill Murali. Give him a problem, put him in a room, and torture him like this. They threaten him to tell the answer. Let's see. Look, it's one line. I did it in one line. If the answer is so simple, it should be so easy. No, 28 by 19, no. One line. If you're doing a lot of calculation, you're doing it wrong. 1 by 9 is 1 by 6 is wrong. Everything is wrong. 5 is wrong. Sorry. You want one line of hint? No, not 20. Not 1 by 9. Okay. Kirchhoff's voltage rule at work. I freaked out the first time I saw this also. Then I was like, what is this? This is one line. Like you see it and know the answer. It's a puzzle, okay? This problem is like a puzzle. There's a puzzle inside this. It's not 0. There's a puzzle inside this. It's not 1. There is a puzzle. Do not calculate. No. Remember the word loop. Remember the word loop. Kirchhoff's law, a loop. Or I'll use one more word. Kirchhoff's law and a special loop. Kirchhoff's law, special loop. Okay, now you're seeing it. Okay. Kirchhoff's law and a special loop. You know, Kirchhoff's law works for all loops, right? Irrespective of whichever loop you take, it works. That's your hint. Done. That's enough, I think. That's enough information to crack this. Don't worry. Everybody crack it at your own pace, okay? No, it's not 4. It's not 4 by 6. And you took the smallest loop you could see there and tried applying it, but that's not simple. You took the smallest loop possible. Why is it called a maze? That's your hint. It's called a maze for a reason. It's a resist. It's a maze. It's a puzzle for a reason. It's not 8. It's not 2 by 3. It's not 4 by 6. It's not 4. The hint lies in the fact the words, this circuit is more like a puzzle. It's a puzzle for a reason. No, it's not 2 by 3. It's not 2 by 3.
No, it's not 1. It's not 1. No, not 0.5. It's like we have slotted all the numbers so far. 0.5, 1, 2, 3, 4, all of them. I told you, right? Kirchhoff's law. But then a special loop. Yeah, that I can't help you. You have to find that loop. You have to find that loop. There is one loop inside this which will do the problem, which will solve the problem in one line. There is one loop inside this. There is one special loop inside this. It will solve the problem in one line. It'll give you one Kirchhoff's equation and you're done. A single Kirchhoff equation you get. Okay, I'll ask you a question. Do you agree currents are different everywhere? Currents are everywhere in this circuit. Everywhere there are different currents. Yeah. So when you apply Kirchhoff's rule, remember to find the potential difference, you have to multiply I into R, the respective current, respective resistor. I1 into R, I2 into R, I3 into R. Agree with that? But what if you could get an equation without all these currents, without any resistances? What if you could get an equation that solves that problem? Anvita, why? Okay. Should I tell the answer, guys? Just the answer. I want to tell you the solution. Okay, okay. Not on the, yeah, Muralidhar got it since. Muralidhar, that's why he's excited. He got the loop. He found that loop. No, it's not a simple loop. Remember that. It need not be, this is not just, okay, by the way, I'll move my cursor, listen up. A loop could be complicated. A loop can go like this also. It need not go exactly in a circle like this. This is a simple loop. A loop can be complicated. A loop can go in very weird ways. This also could be a loop. You're going around completely in a circuit. Okay, that also could be a loop. I didn't say this is a loop. This only is a loop. Loops can be complicated. Loops can be, you can go however you want. One second. Oh, I opened the wrong PPT. One second. Yes. My cursor wasn't moving. I'm sorry. Okay, Muralidhar, cool. But hint is in this picture. One second, I'll show you a picture. The hint is just in this picture. I have not shared that window. One second. Somebody might get it. Somebody might pick it whenever they see this instantly. The hint is here. This need not be a loop. This is a loop. I understand. This here is a loop. But I told you, a loop need not be that. A loop can be complicated. A loop could be like this. This could be a loop. Yeah, this also could be a loop. Oh, sorry. If I didn't start there, if I started and ended here. Yeah. Can you see the pic? Can you see that PowerPoint, this thing? Yeah, okay. Yeah, the point is loop need not be there. Loop could be much more complicated. Okay. So if you go back one second. Yeah. No. It's not that way. Not that way. No, it doesn't depend on that. R1, no. R2. It's all got to do with the loop. There's a special loop. There's a special loop inside this. A very, very special loop. When you discover it, you'll be like, what? The solution to this is brilliant. Okay, just brilliant. Can't be the line. Answer to this is one line. Okay, I'll ask you a question. If the loop has, let's say you find a loop which contains only batteries and the resistor. What if you find a loop which contains only the batteries and the resistor? What will your Kirchhoff's law equation look like? Tell me, what does your Kirchhoff's equation look like? If you find a loop with only batteries, yeah, then all you got to do is apply. Yeah, you're right. No. What if there's a loop? Yeah, there are nodes. There's a loop. What if there's a loop which contains only batteries? Only batteries and no. What if there's a loop which contains only batteries and no this thing, resistors, but contains only this resistor? Can you see a loop which passes through that resistor but contains only batteries? Somebody saw it. Okay. Yeah. Muralidhar got it. Okay. It's there. Got the loop. No, you have to solve it, Amit. If you got the loop, solve it. You should be able to solve it. Once you find that loop, the calculation is like done. One line calculation. Once you find that loop, finding that loop is very hard. It's like a puzzle. But to find where is it that loop? Remember, loop need not be a simple thing. Remember one more thing. Loop need not be a simple thing. Listen. Loop need not be a very simple thing like this. Can you see my cursor? Can you guys see my cursor? No. Wait. No, not 10. One second. Can you see my cursor? Okay, look, I'll try doing something. 1 second. Okay, observe this. You guys can see the diagram now. Can you see the diagram now? Okay. This need not be a loop. This is a loop, I understand. But there are more complicated loops. Agree with that? Even this is a loop, like this. Or even this is a loop, like this. This is a loop. No, Muralidhar, you messed up somewhere. Just messed up. But the idea is this is a loop. You see, I drew a loop, a complicated loop. Do you see that? I drew a very complicated loop. Loops can be much more complicated. It need not be that. I'm saying there is one special loop inside this. To blow your mind, the solution. It's a puzzle. It's more like a puzzle. This loop is more like a puzzle. Nope. Yeah, Satvik has actually got the loop. Even Murali got the loop. Okay, fine. Let's see. Even Amit says he got the loop, but calculation is wrong. Yeah, you should use Kirchhoff's equation for that last part. Once you get the loop, apply Kirchhoff's equation to this. See which direction is the battery and apply accordingly the voltage. Voltage depends on the battery direction. You don't have to apply all the Kirchhoff's equation. You just require the Kirchhoff's voltage rule. That's all.
I hope my calculations are right now. Yeah, pretty sure. No, Sumit, not 4. Can't be 4. Yes, there is, Satvika. Yes, there should be one. You require that. Otherwise, you can't calculate current, right? Yes, exactly. Just the current through that one resistor matters, not the other currents. Yeah, yes, Muralidhar, you're also right. Yeah. See, you just need to require the current through this. We're asking for the current through this I1. You have to calculate I1. Wait, did I mess up? No, I'm worried. Wait. 4, 0, -4. 4. No, I'm right. 4 is not the right answer. Sorry, 4 is not. Not 4 amperes. Not 4 amperes. Okay. Tell me, is this the same loop that you got? Am I going in the same direction as your loop? Yeah. Now, which direction did you turn? Are you going to turn down here? Yeah.
2 amperes I messed up division.
No, wait, don't tell the answer. Yeah, you got it. Muralidhar got it. He messed up division. Last minute division problem. That's all. He messed up division. Yeah. Do you see that? Okay. Did you turn here? Yeah. Then you go like this. Did you turn here, down here? Then you go like this, down here, like this. Satvika didn't go with this loop, I guess. She went to the different one. Or the same one. I went, okay, what's the problem then? Then you're done. You got the loop, you found out the loop which contains only that resistor and the batteries. Okay, understand this. This is +4. Do you agree this is +4? Yeah, this is +4. But this is -4. You're going from a positive to a negative plate. That's what happened. Then you're going like this. This is again -4. This is again -4. Totally you're getting how much? +4, -4, -4, -4. That's -8. Total EMF. Across these points, you had a total EMF of just -8. Yeah, you added. That's all. You messed up in the addition. That's all. It's I times R then. That's it. I times R1. We know R is 4. So done. I is 2. I is 2 amperes. Do you see the brilliance of this problem? It's a puzzle basically. Inside there's a loop which you can't see, which gives you the answer in one line. It's just one line answer if you don't mess up. There are many problems like these are circuit puzzles. You have to like doing like a maze. It's popularly called the Rest Monster Maze. Its original name is Rest Monster Maze. Yeah. This puzzle name is called Rest Monster Maze. Yeah, you can look up. There's also Cap Monster with capacitors. There is one. There are many complicated ones, but the idea is they go on building on this. It's one loop. So remember this: whenever you see a complicated circuit, do not freak out. Okay, do not freak out when you see a very complicated circuit. There will be one loop inside it which will solve the problem instantly, or there'll be some Wheatstone bridge simplification. How to find the loop? You have to figure it out. It's a puzzle. To find the loop, it's a puzzle. I had to do this. I had to sit and think. I started with the resistor. I knew I had to start with this resistor. Then I went on touching the batteries. I didn't touch any resistor. I avoided every resistor possible. That's all. Okay. Yeah. Yeah, Muralidhar will be sleep today. Nice. Yeah. Done, right? Finally. Yeah. Is that fine? Shall we make a move? The time I got the idea to include only batteries, it became clear. Yeah, that's the idea, that you need just batteries and apply Kirchhoff's rule. It's brilliant that you guys did it on your own, figured it out. I would not have done it at your age, at least, on my own, to find the loops. Yeah. So yeah, okay then, yeah. Bye-bye, guys. Take care. Nice talking to you guys. DPP is 1 o'clock. Okay, not possible. I'm sleeping for next 1 hour. DPP coming at 1 o'clock. You will receive a mail at 1 o'clock. I'll code at 1 o'clock. I can't. I'm sleeping now. I'm tired. Seriously, you'll not get the DPP now.
Good night.
Yeah, good night. Yeah, thank you. I'll have to have some coffee before that. See ya. Bye bye. Bye bye. Bye bye.